Hi everyone, welcome to PrepFusion. So what we have been studying? We have been studying about Fourier series. So till now we were studying about exponential Fourier series, but as of now we have stopped exponential Fourier series. Now we are moving towards a trigonometric Fourier series. Okay. So in exponential Fourier series, what do we show? That if xt is even, then x of t is equals to x of minus t, then c of n is equals to c of minus n. If xt is odd, then c of n is equals to minus of c of minus n. So these things we have seen in our exponential Fourier series. The similar thing we need to see in our trigonometric Fourier series as well. That if xt is even, then what will happen to an? What will happen to bn? If xt is odd, then what will happen to an? What will happen to bn? Then there is another thing that is known as half wave symmetry. Okay, in a trigonometric Fourier series, there is one more symmetry that is known as half wave symmetry. So this symmetry we did not see in exponential Fourier series, but this symmetry we are going to see in trigonometric Fourier series. Okay, the name is half wave symmetry. So first let's understand all the symmetry one by one. So first symmetry is known as even symmetry. What is the meaning of even symmetry? That you already know, that x of t should be equals to x of minus t. So this is the meaning of even symmetry, and that you already know how to check. One method I told you, check at x equals to 0 plus and check at x equals to minus 0. Basically what I told you, check at x equals to 0 and check at x equals to minus 0. Basically just ahead and just backward, just ahead and just backward, both values are a only. That means yes, there is even symmetry. This is what I told you, right? Just ahead and just backward. So this x of 0, that can be written as x of 0 plus, and x of minus 0, that can be written as x of 0 minus. So just ahead, just backward. Or what did I tell you? That you take the mirror image about y axis, mirror image about y axis. Now since this graph is periodic, in Fourier series we only deal with periodic graph. Since this graph is periodic, so I will only look at in one time period. In one time period I will look. So in one time period, if I take the mirror image of this graph, what will happen? This will become the mirror image. If I take the mirror image of this graph, then this will be the mirror image. And if both of the mirror image are being superimposed, that means yes, this is even. So basically you need to take one side and take mirror image of that. Just fold this graph here, and after the folding, if they are being superimposed, that means yes, it is a even graph. That means we will call it even symmetry. Here we are giving the name of even symmetry. And what about odd symmetry? Odd symmetry means x of t would be equals to minus of x of minus t. So there what did I tell you? Just check at 0 plus, what is the value? Plus a. And just check at 0 minus, what is the value? Just ahead of 0, the value is a. Just backward of 0, the value is minus a. So here you can see that x of 0 plus is equals to minus of x of minus 0. And if this is the condition, that means yes, this graph is odd. Or what did I tell you? That first take the mirror image and then another mirror image. So basically this graph is also periodic. This graph is also periodic. So this point I can call as minus t by 2 and this point I can call as t by 2, because you can see that this kind of graph is being repeated. Always this kind of graph is being repeated. Always this kind of graph is being repeated. Right? So this point is minus t by 2, this point is plus t by 2. So what do we do? Take the mirror image and then another mirror image. So what will be the mirror image of this particular graph? What will be the mirror image? So this point will come here and this point will come here. So one mirror image and then another mirror image. And if both of these are being superimposed, then yes, this graph is odd. So all these things we have seen in basics of signal. Again I am telling you how to check the odd symmetry, or how to check if the signal is odd or not. So what you will do, first mirror image about, just a second, first mirror image about y axis, first mirror image about y axis, and then another mirror image, another mirror image. So yes, these two graphs are being superimposed, that means yes, there is odd symmetry. Otherwise you can check at just 0 plus and just 0 minus. Say yes or no. Okay. So this is known as odd symmetry, which is very simple. So even symmetry we have studied, odd symmetry we have studied. Now we are going to see about half wave symmetry. Okay. We need to study about half wave symmetry, but let's solve a question. This question is given, xt waveform is given. Okay. They are asking if there is any symmetry present. So till now what you have studied, even or odd. Is this signal even? No. You take the mirror image, this will be the mirror image, right? If you take the mirror image of this particular graph, this will be the mirror image. So this is not even, and certainly it is not odd. Or how you can check? What is the value at x equals to 0 plus? That is 2. And what is the value at x equals to 0 minus? Just ahead of 2, just ahead of 0 the value is 2, and just below 0 the value is 0. No relation, right? No relation. If there is no relation, that means it is neither even nor odd. Now a very important thing is there. Whenever you solve a question based on Fourier series and you need to find an and bn, or you need to find the symmetry, then always the first task that you will do will be to calculate the DC value of the waveform. What you need to calculate? You need to calculate the average of this waveform. What will be the first task? Always, whenever you are solving a problem based on Fourier series, based on trigonometric Fourier series, that you need to find the trigonometric Fourier series, you need to find the a and bn, or you need to find the symmetricity. So whenever I am solving a problem based on symmetricity, I will first thing is I will always find out the average value of the given signal. What is the average value of the given signal? Average value is, this thing I already know, 1 by t naught. Then you need to take the area of one time period. So what will be the area of one time period? That would be 1 by 2 base into height, that would be 1, divided by the time period is also 1. So average is coming out to be 1. Now whatever the average value is coming, that you need to subtract from the xt signal. Basically now you need to draw xt minus 1 signal. Why is that so? If xt is having an average value of 1, if xt is having an average value of 1, then what will be the average value of xt minus 1? That would be 0, right? The average value of xt minus 1 will be 0, because average value of 1 is 1 and average value of xt is 1, so 1 minus 1 will be 0. So basically I need to subtract 1 from this waveform. What I need to do? I need to subtract 1 from this waveform. So what will happen? This waveform will shift downward, this waveform will shift downward. So this 2 will come to 1 and this 1 will come, this 0 will come to minus 1, and here there was 1, so this 1 will come to 0. 2 will come to 1, 1 will come to 0, and 0 will come to minus 1. So this waveform will shift downward. So what kind of waveform we will get? Why we are doing so, you will understand, okay? Always we will do this thing, that whenever we see a question where we need to find the symmetry, so first I will calculate the DC value, and that DC value I will subtract from the given waveform. That's it. This is the task that I will always follow. So this was 2, which became 1, 0 became, at this point you are having 0, at 1 you are having 0. So this became minus 1, at half you are having, here at half you are having the value, here at half you are having the value to be 1, this became 0. Basically the graph is shifted downward. All these things you can do. In basics of signal we have studied all these kind of things. So xt minus 1 versus t, right? So this point is minus 1, this point is minus 1 by 2. Now you tell me if there is any symmetricity or not. Yes, this graph is odd now. How? Take the mirror image. One mirror image you have taken, then take another mirror image, then another mirror image. So yes, they are superimposed. Or what you can do? What you can do is that, let's call this graph as yt. So what you can do? y0 plus, what is the value at y0 plus? That is 1. What is the value at y0 minus? That value is minus 1. This value is plus 1, this value is minus 1. So what you are getting? Y of 0 plus is equals to minus y of 0 minus. That means yes, it is odd. So your xt was neither even nor odd, but xt minus 1 is odd, and we will be using it somewhere, okay? That's why I am teaching you this particular concept. And those guys who are continuously following from the exponential Fourier series, they would have already understood. Because if I subtract a DC value from a signal, then an, bn and cn does not change. Only the DC value will change. Nothing else will change. This we will again prove. But if there is no symmetry in xt, but if I subtract a DC value, then there is a symmetry in xt minus 1. So if I find the Fourier series coefficient of this particular thing, then can I comment on the Fourier series coefficient of this particular thing? Yes. Both will have the same Fourier series coefficient. except the DC value, and DC value I can find out directly from the graph only. Yeah, it might happen that you are not able to understand what I am saying, but until this point you would have understood, right? That xt is having neither even nor odd, but xt minus 1 is having odd symmetry. So using the odd symmetry, I will make a conclusion, and from there we will understand that xt minus 1 will be useful for us. How it will be useful, that we will see. Is that clear to you? So whenever you see a question where you need to find out the symmetricity, first thing always you will see that what is my DC value. DC value is 1. So subtract that DC value and then make the waveform and see what happens. Okay. Well and good. Let's move to the next one. Half wave symmetry. At some places you will find out they are writing it odd half wave symmetry. But if half wave symmetry word is written or odd half wave symmetry word is written, both are the same things. Okay. Both things are the same. In the examination, if they are asking some question on half wave symmetry, then either they will give the waveform or they will write down the statement. They will never say it is half wave symmetry or odd half wave symmetry. So what was the meaning of even x of t was equals to x of minus t, right? What was the meaning of odd? This was the meaning of odd. What is the meaning of half wave symmetry? The meaning of half wave symmetry is you shift your waveform either by plus t by 2 or minus t by 2. Basically, you shift it towards the right hand side or shift it towards the left hand side by t by 2. You shift your waveform by t by 2 either towards the right hand side or towards the left hand side. This should come out to be negative of xt. Is that clear to you or not? Let's see this waveform. What is the time period? 4, right? This time period is 4. So can I call this point as minus t by 4? Yes. Can I call this point as 3t by 4? And can I call this point as plus t by 4? So this window is t by 2, right? This window is t by 2. So any t by 2 window I will take, and then I will shift it. Either I can shift to right hand side or I can shift to left hand side. So usually I will shift to right hand side. So if I shift it to right hand side, then this is what I will be getting. Only what I am doing is that I am taking one t by 4 window and I am shifting it to the right hand side. So I have shifted it to the right hand side. So this is what I am getting. Now again you take the mirror image, because there is a negative sign, no? You can take this negative sign here as well. You can take this negative sign here as well. So again you take the mirror image. So what will be the mirror image of this one? The mirror image will be this one. Are both of them superimposed? Yes. That means certainly there is half wave symmetry. So this is known as half wave symmetry. Again I am repeating, there is a particular waveform. There is a particular waveform given. You saw that the time period is t. This time period is t. Now you need to consider a t by 2 window. T by 2 window you take, you shift it towards the right hand side and then you take the mirror image. If superimposed, then yes, there is odd half wave symmetry, or simply you will call it half wave symmetry. Okay, the odd word can be missed. Why they use odd word? Because there is a negative sign. This is giving a sense of odd signal, right? A kind of sense of odd signal, because in the odd signal as well there is a negative sign. So that's why they call it odd half wave symmetry. And when we study about the effect of all this symmetry, as of now we are just understanding the meaning of symmetry. Like even symmetry, what is the meaning of even symmetry, what is the meaning of odd symmetry, what is the meaning of half wave symmetry. As of now we are just understanding the meaning. Then we will see what will be the effect on A and B and. So when you see the effect, then you will also understand why it is known as odd half wave symmetry. Okay, but odd word can be missed. In textbook you will always find only half wave symmetry word is written. They are missing this odd word. Okay, so you can drop this odd word. Only half wave symmetry you will call it. Okay. So what you need to do, this way you can shift, just take any t by 2 window, shift it and then take the mirror image. Superimposed, yes, there is half wave symmetry or odd half wave symmetry. Or what you can do, put t equals to 0 here. So what you will get, plus minus t by 2. I am taking the case of plus sign. Okay, so put t equals to 0 here, plus minus t by 2 is there. So either you take plus or you take minus, both are the same things. So x of t by 2 plus should be equals to the minus of x of 0 plus. Basically in place of t I am putting 0 plus. So 0 plus plus t by 2. That means just ahead of t by 2. Right, and here just ahead of 0. So just ahead of 0, what value I am getting? just ahead of 0, what value I am getting? A. And just ahead of t by 2, what is, this is your t by 2, right? This is minus t by 4, this is plus t by 4, this would be t by 2, and then 3t by 4, because this window is also t by 2. So this would be t by 2. This is 0, this is t by 4, this is t by 2, this is 3 by 4, and this is minus t by 4. This point will be t. I hope this is clear. At least this much basic things is clear to you, right? So this point will be t by 2. So x of t by 2 plus, what is the value? The value is minus a. Are both of them coming negative of each other? Yes. That means there is half wave symmetry. Okay. But there is one exception in this particular method. Okay. This particular method is not always true. What is the exception? That we will see. So as of now, we have studied about odd half wave symmetry or simple half wave symmetry, that you shift your waveform and then you take the mirror image. In even, what do? Take mirror image about y axis. In odd, what do? Take mirror image and then another mirror image. In half wave symmetry, what do? Shift and then take the mirror image. All good? Now this method we have used. So try applying the same method in this particular question. Okay. So is this periodic? Yes. What is the time period? Time period is 3. Time period t equals to 3. What point this will be? Minus t by 3. And what point this will be? 2t by 3. Because minus t by 3, 2t by 3 total time window is t only. And how did I find out this is minus t by 3? Because time period is 3. So 3 divided by 3 will give you 1. So minus t by 3. This point would be 0. This point will be plus t by 3. Right? So what method I will apply? That sir, x equals to 0 plus. What is the value? A. And x equals to, sir, t by 2 plus. T by 2. Where will be your t by 2? T by 2 would be somewhere in between. Because this is 0.33t. And what is this? 0.67t. So t by 2, that means 0.5t would be somewhere here in between. Are you getting this point? T by 3 means 0.33t. 2t by 3 means 0.67t. That means 0.5t would be somewhere here. And what is the value there? That is minus. So from here you are saying that my x of 0 is coming out to be minus x of t by 2 plus. And sir, yes, this condition is being satisfied. So can I say there is half wave symmetry? And here if you said this particular thing, then it is wrong. Because it is pretty obvious. What you need to do, you need to take the t by 2 window and then shift it and then take the mirror image. So in this particular waveform, take the t by 2 window. What you need to do? Take that t by 2 window. So time period is 3. This point is minus 1. What this point will be? 1 by 2. So this window will be 3 by 2, or you can say this window will be t by 2. Are you able to understand this point? First I saw the time period. Time period is 3. Okay. Time period is 3. Now I need to find the window of t by 2. This window of t by 2 I find out. How did I find it out? Because time period is 3. So window of t by 2 would be 3 by 2. This window is already 1. I need another half window. So another half. So this window is t by 2. Now I will shift this waveform. I will shift this waveform here. So this is what I will get. If I shift this waveform here, so this is what I will be getting. And then you take the mirror image. You take the mirror image. So this will be the mirror image. So are two graphs being superimposed? This is this graph and the another graph is this. So are both of them superimposed? Absolutely not. So if they are not being superimposed, that means certainly there is no half wave symmetry. No half wave symmetry. So actually when you look at the graph, there is actually no half wave symmetry. Again I will be repeating what I did. First I found out the window of t by 2, then I shifted it and then took the mirror image. Shifted, took the mirror image. So are both of them superimposed? This graph and this graph, they are certainly not superimposed. That means there is no half wave symmetry. No half wave symmetry. But here this method is failing. So this method will be applicable only when DC value is 0. What is the DC value of this graph? What is the DC value? Positive area? is equals to negative area. So here for this graph the DC value is 0. So here this method was applicable. DC value is 0, this method is applicable. In this question, this method is not applicable. Which method? This method. So this will work only when DC is 0. What is the DC value of this graph? Let's find out that DC value of this graph. What that is? Area of this particular graph, that is 2a. Area of this graph, that is minus a, divided by the time period. So DC value is a by 3. It is not 0. If I need to make the DC value 0, what I need to do? From xt I need to subtract a by 3. If I need to make DC value of this graph 0, what I will do? I will subtract a by 3 from it. So what will happen? A will reach to 2a by 3 and minus a will reach to minus 2a by 3. Are you able to understand this point? I need to make that DC value equals to 0. So from a if I subtract a by 3, where I will reach? 2a by 3. From minus a if I subtract a by 3, where I will reach? Minus 2a by 3. So this kind of graph I will get. 2a by 3, sorry. What did I say? From a I need to subtract a by 3. So where I will reach? 2a by 3. And from minus a if I need to subtract a by 3, then where I will reach? Minus 4a by 3. Okay. So 2a by 3 to minus 4a by 3. 2a by 3 to minus 4a by 3. So this is what I am getting. Now here I can apply that method. Which method I can apply? That x of, let's call it yt. Let's call it yt. So here I can apply this method that 0 plus, what is this window? This time period did not change. If you subtract a DC value, that doesn't mean the time period will change. Time period remains the same. So this window is t and this window is t by 2. Although this is not a matter of concern. What is this point? This point is minus t by 3. This point is 0. This point is plus t by 3. This point is 2t by 3. And this point somewhere in between is t by 2. Right? Let's call it yt. So what is the value of y of 0 plus? So y of 0 plus is 2a by 3. And what is the value of y of t by 2 plus? Y of t by 2 plus is minus 4a by 3. And then there is no relation. There is no relation. 0 plus is 2a by 3 and t by 2 plus is minus 4a by 3. There is no relation at all. If there is no relation, that means no half wave symmetry. And if yt is having no half wave symmetry, in yt if there is no half wave symmetry, then certainly in xt as well, which is equals to yt plus a by 3, that will also not have any half wave symmetry. So this shortcut method is applicable only when the DC value is 0. So if this DC value is non-zero, then you make it 0 and then you check. Otherwise what you do? You find out a window of t by 2, shift that and take the mirror image. I guess that is the easier method, I guess. Two method I have told you. 0 plus, t by 2 plus, check. If they are coming negative of each other, half wave symmetry is there. Otherwise, take a window of time t, then take the half of that window, shift it and take the mirror image. All good? But always take care of this thing, that whenever I deal any problem based on symmetricity, always I will check after making the DC value equals to 0. What I will do? Always first task would be that make the DC value equals to 0. Because it might happen that in first glance, if these kind of waveforms are coming, then you will feel like that, okay, there is no symmetricity. But when you make the DC value equals to 0, you find out some symmetricity there. Right? Is there any half wave symmetry in this particular graph? What I am saying, is there any half wave symmetry in this particular graph? There is odd symmetry, that's for sure. Is there any half wave symmetry? What is the DC value of this graph? 0. DC value is 0. So I can apply that formula. X of 0 plus, what is that? 1. Basically this time window is t and this time window is t by 2. So you take this window, you shift it and then you take the mirror image. You shift it and then you take the mirror image. So what will be the mirror image? This will be the mirror image. So are both of them being superimposed? One waveform is this, another waveform is this. Both of them are not being superimposed. So here directly you can see that there is no half wave symmetry. No half wave symmetry. Or what you can say, at x equals to 0 plus, what is the value? 1. At x equals to t by 2 plus, what is the value? Nearly 0. At x equals to t by 2 plus, value is nearly 0. No relation. So there is no half wave symmetry, right? Let's get back to more examples. What about this question? What is the DC value? This waveform and this waveform both are same only. This waveform and this waveform both are same only. So let's not discuss it. There is also no half wave symmetry because at 0 plus and at t by 2 plus different values are there. What about this one? Let's take the example of this particular waveform. Is there any half wave symmetry? What you will say? That sir, this is the window of t, or you can say sir, this is the window of t. Or directly I can see this is the window of t. If I shift this and then take the mirror image, there is no chance that there will be half wave symmetry. But what did I tell you? That whenever you deal a problem based on half wave symmetry, what is the first task you will do? Always make the DC value equals to 0. Is the DC value 0 here? No. So what is the first task? Make the DC value equals to 0. So let me add a page and take this signal. Okay. We will check whether there is half wave symmetry or not. Okay, this example I have already taken here. Okay, this example I have already taken here. So let's solve this example. So just by looking at this particular graph, you will never ever tell that sir it is not having half wave symmetry. Just by looking at this graph, you will tell that sir yes it is even. That's for sure. But looking at this graph, it feels like that sir there is no half wave symmetry, right? There is no half wave symmetry because what you can see, if I shift this graph, this is the window of t by 2, right? This is the window of t by 2. So if I shift this graph, then somewhat like this I will be getting. Just shifting this graph, somewhat like this I will be getting. What I am doing, I am just shifting this much portion. Then this is what I will be getting. And then I take the mirror image. The mirror image will be like this. So are both of them superimposed? No chance. No chance they are superimposed. So here directly you can tell that sir there is no chance there will be half wave symmetry. But what did I tell you? Always subtract the DC value. So let's find out the DC value for this one. So this is the window of t, right? So what is the area? Area is 1 by 2 into base into height divided by the time period. So DC value is a by 2. So now I need to subtract a by 2 from here. So a will reach to a by 2. A minus a by 2 will be a by 2. A by 2 will reach to 0 and 0 will reach to minus a by 2. So what kind of waveform you will get? A will reach to a by 2. A will reach to a by 2, then minus a by 2, a by 2, 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 xt minus a by 2. A by 2 minus a by 2. This point is 1, this point is 2, this point is 3. Basically 0 is reached to minus a by 2. This is what I am saying. And a is reached to plus a by 2. This point is 4, this point is 0, this point is minus 1, this point is minus 2, this point is minus 3. Wait a second. Okay, sorry. This point is not minus 1. Actually, this point is minus 1, right? Because 0 is reached to minus a by 2. This point is minus 1. Okay. So what I need to do? I can see this is the window of t. Or what I can do, here DC value is 0, right? In this particular graph, DC value is 0. DC value is 0. So if DC value is 0, then I can apply this particular method. Just at t equals to 0 plus, what is the value? A by 2. Just at t by 2 plus. Just at t by 2 plus. So what is the time period here? Time period you can directly see. What is the time period? So this waveform is being repeated. This waveform is being repeated. Or how you can see, this much part is being repeated. So time period is 2 here. Here also you can see time period is 2. So from here directly I can say that time period is 2. This time period is 2. So this point will be t by 2. Because this time period is 2, so this point will be t by 2. You just need to locate t by 2 point. So this point will be t by 2. So what is the value at t by 2 plus? T by 2 plus, the value is minus a by 2. So yes, I can see that this is the scene. That means yes, okay, let's call this as yt, this as yt. So this would be y here. So y of 0 plus is a by 2, y of t by 2 plus is minus a by 2. So y of 0 plus is equals to y of 0 plus will be equals to minus y of t by 2 plus. So from there I can say that yes, half wave symmetry is there. So if your yt is having half wave symmetry, then you will comment on yt, and from this comment you can comment on xt as well. Because if I know the Fourier series coefficient of yt, then certainly I can tell the Fourier series coefficient of xt as well, because Fourier series coefficient of xt will be same only. What I mean to say is that if I know the Fourier series coefficient of yt, then the Fourier series coefficient of xt will be same, only difference will be of dc value, and dc value I can find out this waveform only. Are you able to understand this point? So in yt there is half wave symmetry, so certainly in xt as well, if I am able to comment on yt, then I can comment on xt as well. Say yes or no. So always the first task would be the subtract the dc value, that's it. So just by looking at this waveform, I will not comment anything. First I will subtract the dc value. When I subtracted the dc value, again it is even only. Certainly it is even. So your yt is even, along with that it is having half wave symmetry as well. Say yes or no. Or what you could have done, like this was the method, or what you could have done is that you could have find out the window of t. This is the window of t. Then you could have taken t by 2 window. This would have been the t by 2 window. Then you would have shifted it and then taken the mirror image. So you will shift this one. You will shift this one, and then you take the mirror image. So this negative part will become the positive part, and this positive part would have become the negative part. So yes, it is being superimposed. Or what you could have done, this window I will take, this small window I will take, and then I will shift it, and then I will take the mirror image. What I have done, this window I took, shifted it, and then took the mirror image. Basically you need to take a time window of time t. This is also time t. Then you take the half window of it, shift it, and then take the mirror image. So if they are being superimposed, then that means certainly there is half wave symmetry. And what would be the easier method? If you have done that dc value equals to 0, because in 99% of the questions of symmetricity, in 99% of the questions of symmetricity, you will have to make dc value equals to 0. So if dc value is 0, then you can apply this method. Check at 0 plus, check at t by 2 plus. Just you need to mark t by 2 and you need to mark 0. So if you just check that, then you will see if they are negatively related or not. If they are negatively related, then there is half wave symmetry. Try this one on your own. Is this graph even or odd? No, neither even nor odd. This is neither even nor odd. Along with that, DC value is also 0, because what is the time period? This is the time period. And why it is neither even nor odd, you can check, right? By the mirror image concept, you take the mirror image, this will be the mirror image, and then you take another mirror image, so this will be the mirror image. Basically, first I will take the mirror image of this particular graph, that would be this one, and then another mirror image, so that would be this and like this. So this graph and this graph, they are not superimposed. Or how I can check? How I can check? At t equals to 0 plus, at t equals to 0 plus, the value is 0, and at t equals to 0 minus, t equals to 0 minus, the value is minus a. There is no relation. That means it is neither even nor odd, right? So this job is done. Now you need to check the symmetricity. So directly I can see this window is t by, or what you can do, the DC value is 0. What is the value? What is the DC value? DC value is 0. So what method I can apply? Check at 0 plus and check at t by 2 plus. So what is the value at 0 plus? That is 0 only. And what is the value at t by 2 plus? That is also nearly 0. So can I write down 0 plus is equals to minus of t by 2 plus? Yes, because 0 is equals to minus 0. So yes, there is half wave symmetry. Or what you could have done, shift this graph. This is the window of t. Then this will be the half time window. Shift this graph. Shift this graph. And then take the mirror image. Then take the mirror image. Yes. Shifted and taken mirror image. So yes, you are getting the half wave symmetry. So this is how we will check the symmetricities. Is that clear to you? Then there is something called quarter wave symmetry. So for that I need to take a break, and then we will start quarter wave symmetry. So as of now, the conclusion you have already seen: even, odd and half wave symmetry. Half wave symmetry was new to you. In half wave symmetry I told you two methods: find out the window of time t Then find out the window of time t by 2, shift that and take the mirror image, or make the DC value equals to 0, and after that do the same process, or you check at 0 plus t by 2 plus. Are you able to understand this point? So whenever we solve a question based on symmetricity, always we will make the DC value equals to 0, and after that we will analyze it, because after making DC value equals to 0, we find out a lot of new things, right? Then we will study about quarter wave symmetry. Okay, so let me take a break and then I will come back. Yeah, welcome back. So let's study quarter wave symmetry. So quarter wave symmetry is nothing but if your signal is having even or odd symmetry, even or odd, plus it is having half wave symmetry, then it is known as quarter wave symmetry. Okay, quarter wave symmetry. Even or odd plus half wave symmetry. Like previously we have seen this example we have seen, right? This was even as well, along with that it was having half wave symmetry as well. That means it is having quarter wave symmetry as well. So more example we will see. Let's see this example. Is this example even? Yes, it is even. Directly I can see, right? Take the mirror image, or you check the value at t equals to 0 plus, you check the value at t equals to 0 minus, plus a plus a. That means both are equal, so it is even. What is the DC value of this graph? DC value is also 0, because this is the window of time t. So if DC value is 0, then I can apply the method. Which method I can apply? 0 plus and t by 2 plus. 0 plus is a, t by 2 plus. If this window is t, then this window is t. What is this t window? This window is t. So this would be t by 2, right? Because the time period is 4 here. Time period is 4, so this point will be t by 2. So what is the value at t by 2 plus? That is minus a. So from here what I can say? Half wave symmetry is also there. Or what you could have done? This window is t. So what will be this window? This window will be t by 2. So you shift this waveform, and then take the mirror image. So both are being superimposed. That means yes, half wave symmetry is there. So here even plus half wave symmetry is there. What does that mean? It is quarter wave symmetry. Okay, so this is known as quarter wave symmetry. What about this one? Is this graph odd? Yes. Take the mirror image and then another mirror image of this one. So another mirror image, that means both are being superimposed. Or what you can check? At t equals to 0 plus, the value is just greater than 0. So you can write down plus 0. And at t equals to 0 minus, the value is just less than 0. Then you can write down minus 0. So both are negative of each other? Yes. That means certainly it is odd. So odd I can check. Next what I need to check? I need to check the half wave symmetry. So what is the time window t? This time window t I can take from minus t by 2 to plus t by 2. This time window I can take. What I need to do? Shift it and then take the mirror image. Both are being superimposed. That means yes, it is half wave symmetric as well. Or what is the DC value? DC value is 0. Then what you would have checked? At t equals to 0 plus, the value is just greater than 0. And at t equals to t by 2 plus, the value is just less than 0. So from here what I can say? 0 plus is equals to this thing. What does that mean? Yes, half wave symmetry is also there. So this graph is one of even or odd. Like the graph is even, along with that it is odd. It is not possible, right? One graph together cannot be even and odd. Either it will be even, or it will be odd, or it will be neither even nor odd. So it is odd, plus it is having half wave symmetry as well. What does that mean? That means it is quarter wave symmetric. So for symmetricity we have seen even, odd, half wave symmetry and quarter wave symmetry. So even you know, half you know, even symmetry you know, odd symmetry you know, half wave symmetry you know, and now you know the quarter wave symmetry as well. Some simple mathematics, let's see some simple mathematics, because it will be used somewhere. That's why we are seeing this mathematics. Okay, our next topic is effect of symmetricity on trigonometric Fourier series. So this topic we are going to see, but before that let's see a simple mathematics. What is the value of sine theta plus minus pi? So first let's see sine theta plus pi. Sine theta plus pi. Can I write it down as sine pi plus theta? Sine pi plus theta. Sine pi plus theta. That means which quadrant? Third quadrant. In third quadrant, all student take. So in third quadrant, sine is negative. So this would be minus sine theta. What about sine theta minus pi? Can I write it down as minus sine pi minus theta? Because if I take the negative sign, then it will come as negative. So what is sine pi minus theta? Sine pi minus theta, that means second quadrant. So this sign is positive, but already there is a negative sign. So answer is, in both of the cases, answer is minus sine theta. Just telling you because I will be using it somewhere. You don't need to remember it, but I will be using it somewhere in the derivation. At that time, I will not be teaching you all these kind of things. So that's why I always teach mathematics beforehand. Cos theta plus pi. Cos theta plus pi can be written as cos pi plus theta. Cos pi plus theta. That means third quadrant. Minus cos theta. Cos theta minus pi can be written as cos pi minus theta, because cos has the ability of eating up the negative sign. That means second quadrant. So minus cos theta. So what is the answer? Minus cos theta. Sin theta plus 2 pi, or you can write down sin 2 pi plus theta. What does that mean? First quadrant, positive. Sin theta minus 2 pi, or what you can write down, minus sin 2 pi minus theta. That means fourth quadrant. So sin is negative, negative, negative will make it plus. So what is the answer? Sin theta plus minus 2 pi is equals to sin theta. And similarly, this will come out to be cos theta only. Let's check. Cos theta plus 2 pi can be written as cos 2 pi plus theta. Cos 2 pi plus theta means first quadrant. And cos theta minus 2 pi, that can be written as cos 2 pi minus theta, but negative sign comes outward. 2 pi minus theta. All student take, wait a second. Oh, sorry, really sorry. Negative sign will not come outward, no, because cos has the ability of eating up the negative sign. So cos 2 pi minus theta, that means it will be fourth quadrant. So all student take coffee. Fourth quadrant, cos is positive. So this is equals to cos theta. So these are the answers. Okay. So theta plus minus pi, if this case is coming, minus sin theta. Theta plus minus pi, minus cos theta, and theta plus minus 2 pi, then positive sign. Okay. So I will be using it somewhere. Let's start our chapter now. Till now we were just introduced to symmetricity. Now we are going to start our chapter. Now we are going to study about the Fourier series again. So effect of symmetricity on trigonometric Fourier series. So this is the trigonometric Fourier series. We represent our xt in terms of a DC and in terms of cosinusoids and sinusoid of frequency omega naught, 2 omega naught, 3 omega naught, and so on. Right? So DC plus a1 cos omega naught t plus a2 cos 2 omega naught t. In that manner it will keep on going. Same goes for sinusoids as well. Sin 2 omega naught t. Okay. In that manner it will keep on going. And these are the formula of an, bn and c naught. C naught is just the DC value. This we already know. An formula 2 by t naught. Then you need to integrate for a time period xt cos and omega naught t. This also we have already studied. And bn formula also we have already studied. So these formulas we will be using it somewhere. That's why I have written it down. Let's start. If your xt is even, then what will happen to your an and bn and c naught as well? So if your xt is even, then what is the meaning of xt is even? That x of t should be equal to x of minus t. So if I find out x of minus t, what will happen? X of minus t. What is the ability of cos? Cos will eat up the negative sign, right? If I put minus t here, it will become cos of minus omega naught t. Cos will eat up the negative sign. Here also cos will eat up the negative sign. So all the cos, whatever the cos are present, all will eat up the negative sign. But what about the sign? If you put minus t here, then sign will take up the negative sign outward. So this will become minus b1 sin omega naught t. This will become minus b2 sin 2 omega naught t. In that manner it will keep on going. Right? In that manner it will keep on going. What I need to do? Both are even, that means I need to equate them. So when I equate these two, what will happen? C naught will become equals to C naught. This part will become equals to this part, which is pretty obvious. 2 will be equals to 2 only. Let's just say this value is 2. So 2 will be equals to 2, 3 will be equals to 3. But what do you see here? What do you see here? That plus b1 sin omega naught t is equals to minus b1 sin omega naught t. b1 sin omega naught t is equals to minus b1 sin omega naught t. When it can be possible? When b1 is 0, or how you can see that this, if I take here 2b1 sin omega naught t. Now if cos omega naught t exists, that means sin omega naught t will also be non-zero. What do I mean to say is that, let's just say cos omega naught t is 1 by 2. So what will be the value of sin omega naught t? Because cos square omega naught t plus sin square omega naught t is equals to 1. So what that would be? This would be under root 3 by 2. So sin omega naught t will be under root 3 by 2. So basically this would be non-zero. Now here your 2b1 sin omega naught t is coming out to be 0. What does that mean? That b1 has to be 0. Same goes for b2 as well. Same goes for b3 as well. In the same manner, all your bn has to be 0. So what did you understand from here? That if your xt is even, then an can be non-zero. Even c0 can be non-zero because c0 is also coming out to be equals to c0 only. So c0 can also be non-zero. But they can be 0 as well. We are not sure about it. Non-zero or 0. What I mean to say is that c0 can be non-zero or 0 as well, because 0 is also equals to 0. Basically, we need to make c0 equals to c0. What is c0 is 0. So 0 is also equals to 0. Are you getting this point? So they can be 0 as well. But surely bn has to be 0. Are you able to understand this point? Do you need to mug up all these things? No. Because the basic thing is, if there is a periodic signal, then I can represent the signal like this. Now I am saying that my function has to be even. My function has to be even. In the signal there are cosinusoids and there are sinusoids. Cosinusoids are already even and sinusoids are odd. If you want your signal to be even, that means only even components should be present. No, odd components should be 0. And if odd components should be 0, that means bn has to be 0. There you go. Basically, this is my signal, right? I want this to be even. I want this to be even. That means here also everything should be even, no? But you know this thing that this is odd. And if I want this to be even, then only even components should be there. In even graph, the DC value can be 0 as well, it can be non-zero as well. So I am not caring about DC, but certainly this bn has to be 0. That's it, very simple thing. Are you able to understand this point or not? Very, very straightforward thing. That if I want my xt to be 0, sorry, if I want my xt to be even, then only even part should be there, which is this one. So only this part should be there. Are you able to understand this point? Right? Or this was the method 1. N number of methods are there. xt is even, right? So what I can write down? C of n is equals to C of minus n. What is your an? An is Cn plus C of minus n, right? Cn, C of n is equals to C of minus n. That would be equals to 2Cn. And what about Bn? Bn is J Cn minus C of minus n, right? Cn minus C of minus n. So J Cn. What is C of minus n? That is Cn only. That is also equals to 0. So Bn is coming out to be 0. This is coming out to be some non-zero. And this is coming out to be 0. So here also you got to know that your An is non-zero and Bn is 0. This was the method 2. What could be the method 3? Use this formula. Xt is even. This graph is also even. Cos is already even and xt is also even. Even multiply with even. What it will make? Even into even. Even into even. Both will eat up the negative sign. Both will eat up the negative sign. That means graph will be even only. So even into even will be even. And when you calculate the area of even, it could be non-zero. Basically, is this graph even? Yes. This graph is even, right? This graph is even. If you calculate the area for one time period, it could be non-zero. But if the graph is odd, is this graph odd? Yes. If the graph is odd, then certainly DC value has to be 0. Basically, the area of one cycle has to be 0 if the graph is odd. What do I mean to say is that here what is xt? Xt is even. This is given in the question. What is sin t? Odd. Even into odd. One as it is, another one take out the negative sign. So what it will become? Odd only. So even into odd will become odd. if you take the area of a odd signal for one time period, that would be 0 only. Here also it could be 0, but always it is not necessary. What I mean to say is that in this case as well, this value can come out to be 0, but not always. But here always it will be 0. Can you tell me any odd signal where the area of one time period is not equals to 0? There is no signal like that. There is no odd signal like that where area of one time period is not equals to 0. Always the area of one time period will be equals to 0. So this area of one time period will be equals to 0. Are you able to understand this point? Are you able to understand this method 3? Even into even will make it even. And if you take the area of a even signal for one time period, it could be 0 or non-zero. So I am not commenting anything on an, but surely my bn would be 0. Because even into odd will make it odd, and when I calculate the odd function for one time period, when I calculate the area of odd function for one time period, that will certainly be equals to 0. So bn will certainly be equals to 0. So n number of methods, so 3 methods I have told you, and you will be able to keep in mind very easily. The easiest one is that this is my xt. My xt is written in cosinusoids and sinusoids. If I want my xt to be even, that means only cosinusoids has to be 0. What I mean to say is that if I want my xt to be even, then only cosinusoids has to be there. Sinusoids has to be 0. That's it. That means bn has to be 0. Are you able to understand this point? That means if xt is even, then xt will be written as some dc value plus n goes from 1 to infinity an cos n omega naught t, right? Okay. Now another thing, let's write down the formula of an. What is that? 2 by t naught. Can I take the window from minus t naught by 2 to plus t naught by 2? Say yes or no. What I am doing, I am breaking down the window, right? Here I need to take the window of t naught. So I am taking the window from minus t naught by 2 to plus t naught by 2. That means this window is of t naught only. xt cos n omega naught t dot dt. This is even, and this is also even. So minus t naught by 2 to plus t naught by 2, multiplication of both of them will also be even. So if I make this graph, let's just say, is this graph even? Yes. Minus t naught by 2 to plus t naught by 2. So whatever the area I will get from minus t naught by 2 to 0, the same area I will get from 0 to t naught by 2 as well. So can I break down the limit into, how I can break down the limit? 2 by t naught into 2 from 0 to t naught by 2 xt cos n omega naught t dt. Did you understand this point? How did I break down the limit? Because I know that if my graph is even, then whatever the area you will get from minus t naught by 2 to 0, the same area you will get from 0 to t naught by 2 as well. So this is how you can break down your limit. And what is the formula of an is coming out to be? So formula of an I have reduced. Okay. And instead of writing from 0 to t naught by 2, here I will write down the window of t naught by 2. Window of t naught by 2. So instead of writing 0 to t naught by 2, I have written down the window of t naught by 2. So this is the formula of an. And bn is surely 0. Bn is surely 0. So an will depend on this formula. It can come out to be 0 as well. It can come out to be non-zero as well. I don't care about that. But certainly bn will be surely 0. Is that clear to you or not? This discussion is clear to you or not? The only new thing that you have studied here is that this formula. And this is very easy to remember. How? Do you remember this formula? Do I remember this formula? That I take the window for t naught xt cos n omega naught t, whatever it is, dot dt. Then what do I write down here? 2 by this window. Here also I am doing the same thing. In this formula also I am doing the same thing. What window I am taking? If there is even symmetry, that means I am taking the window of t naught by 2. So 2 by this window, that is t naught by 2. So if this goes upward, what it will become? 4 times. So 4 by t naught, and then whatever I repeat here. 2 by window, that's it. 2 by window. This is what you need to remember. Don't mug up like 2 will come here, 4 will come here. In that manner you will get confused. In Cn, 1 by t naught comes. Cn is made from an and bn, an minus j bn by 2. So here 2 by t naught comes, here also 2 by t naught comes. Basically 2 by the window. So here what will be the scene? What will be the scene? 2 by the window. 4 by t naught, right? Okay, this we have seen about even. Now do the same for odd. Do the same for odd. What do you think? What should be 0? For the odd signal, what is the criteria? X of t should be equals to minus of x of minus t. So if I find out x of minus t, what will happen? The C naught is as it is. This sinusoids will take out the negative sign. These sinusoids will take out the negative sign, but cosinusoids will eat up the negative sign. Right? What I need to do? X of t should be equals to minus of x of minus t. That means C naught should be equals to minus C naught. B1 sin omega naught t should be equals to minus of minus B1 sin omega naught t. So minus minus will get cancelled out. So B1 sin omega naught t should be equals to B1 sin omega naught t, which is pretty obvious. A value 2 will be equals to 2, Ram will be equals to Ram, Sham will be equals to Sham, Mahesh will be equals to Mahesh. So which is pretty obvious, but A1 cos omega naught t should be equals to the negative of this minus A1 cos omega naught t. What does that mean? 2A1 cos omega naught t should be equals to 0. So from here what is coming out to be? A1 is equals to 0. Or what you can write down, that An has to be 0. Along with that, C naught has to be equals to minus C naught. What does that mean? That 2 C naught has to be equals to 0. That means C naught also has to be equals to 0. What does that mean? If your graph is odd, then DC value also has to be equals to 0. Only Bn can be non-zero. Say yes or no. If the graph is odd, then only Bn can be non-zero, which is pretty obvious. Again, why is that so? Because if this is my xt, and I want it to be odd, here did I say even? Here I mean to say odd, okay? If my graph is odd, then your An has to be 0, C naught has to be 0, and Bn has to be non-zero. I can say from here as well, if I want my graph to be odd, then this value should also be odd only, right? And one thing I already know, if there is an odd graph, then surely DC value has to be 0. If there is an odd graph, DC value has to be 0. Cosinusoid is even and sinusoid is odd. Now if I want this to be odd, then only odd component should be 0. If I want my graph to be odd, then only odd component should be there. So that means only sinusoid should be there, cosinusoid should be equal to 0. Are you able to understand this point? Very, very basic thing. If my graph is odd, what does that mean? That means only sinusoid has to be there. If only sinusoid has to be there, that means Bn has to be non-zero. Rest all the things should be 0. But in a odd graph, this is also a very important, that DC value has to be 0. But in even graph, DC value not necessary to be 0. It could be 0 as well, or it could be non-zero as well. You can take two cases. Here what is the DC value? Is this graph even? Yes. What is the DC value here? Directly you can see it is non-zero. Is this graph even? Yes. What is the DC value here? It is 0. DC value here is 0, right? But here it was non-zero. So in even graph, you cannot comment on DC value. It could be 0 or non-zero. But in odd graph, you take any example of odd graph, always the DC value has to be 0. Okay? Any example you take of odd graph. Any example you take. Is this actually odd? Yes. Yeah, this graph is odd, right? You can see directly here. DC value is 0. Or you simply take sinusoid only. Sinusoid only. The sinusoid you take. So for one time period, DC value is 0 only. Positive area is equal to negative area. So in odd graph, the DC value has to be 0. So this was the important point here. Well and good. More method you can see, method 2. What is that? X of t is equals to minus of x of minus t. That means Cn is equals to minus of C of minus n. What is the value of An? An is Cn plus C of minus n. That means Cn, C of minus n is equals to minus Cn. Should be equals to 0. There you go. So An also has to be 0. And from here, if you put 0, n equals to 0. If you put n equals to 0 here, what you will get? C of 0 should be equals to minus of C of minus 0. That means C of 0 will be equals to minus C0. From here, what you are getting? That C0 should be equals to 0 only. So from here, C0 equals to 0 you are getting. Along with that, An equals to 0 also you are getting. So two things you are getting. So this is the method 2. And Bn will be non-zero, you can check as well. Are you getting this point? Very simple thing. Very, very straightforward thing. Right? Now we will see the formula. And this is what we have seen, right? Or here I will write down what will be my xt. So xt, if xt is odd, then my xt will simply be no dc value, only n goes from 1 to infinity, bn sine n omega naught t, no dc value there. Okay, let's see the formula. In the similar manner, like whatever the thing that we have done, bn is equals to 2 by t naught window xt sine n omega naught t dt. What is this? Odd. And what is this? This is also odd. xt is odd, sine n omega naught t is also odd. Odd into odd will make it even. Why is that so? Because one will take negative sign outward, then another guy will also take negative sign outward. Negative will become positive. So odd into odd will be even only. So what this graph has, what this particular thing has become? Even. Both combined has become even. And if it is even, then you can break down the limit. How will you break down the limit? Twice of this. Basically whatever the thing that we have done previously. Take the window to be t naught by 2. Here window was t naught. Take the window to be half and then make it twice. xt sine n omega naught t dt. So this is the formula of Bn. It could be 0 or non-zero, I don't care, but certainly An has to be 0 and C0 also has to be 0. So two things we have studied till now, even and odd. If it is even, then C0 value I cannot comment, but Bn value surely be 0. That means there should be no sinusoid. Only cosinusoid should be there. And An formula can be written as 4 by t naught xt cos n omega naught t dt. If it is odd, then dc value has to be 0. Along with that, sinusoids should also be 0. Sorry, cosinusoid should also be 0. Only sinusoid has to be there. So sinusoid has to be there. So Bn can be non-zero. And what will be the formula? 4 by t naught, 0 to t naught by 2, or you can say window of t naught by 2, xt sine n omega naught t dt. Well and good. Let's move to the next one. Xt is half wave symmetric. Okay, xt is half wave symmetric. So what was the thing? That x of plus minus t by 2 should be equals to minus of xt. So again I have to write down xt, that is dc a1 cos omega naught t plus a2 cos 2 omega naught t plus a3 cos 3 omega naught t. In that manner we will keep on going. b1 sin omega naught t plus b2 sin 2 omega naught t plus b3 sin 3 omega naught t, and in that manner it will keep on going. So x of t plus minus t by 2 a1 cos, in place of t what I need to put? T plus minus t by 2. So omega naught t plus minus omega naught t by 2. In place of t you need to put t plus minus t by 2. So omega naught t plus minus t by 2. So omega naught t plus minus omega naught t by 2. What this value will become? What is the value of omega naught into t? That is 2 pi. So what it will become? Omega naught t plus minus pi. Cos omega naught t plus minus pi. Cos omega naught t plus minus pi. Cos omega naught t plus minus pi is equals to minus cos theta. Are you able to understand this point? Are you able to understand this point or not? So what this became? Minus a1 cos omega naught t. Say yes or no. Are you able to understand this point or not? Again, let's see. In place of t, we need to put t plus minus t by 2. So omega naught t plus minus omega naught t naught omega naught t by 2. Omega naught t is 2 pi. Omega naught t is 2 pi. So this will become omega naught t plus minus pi. So this particular thing is omega naught t plus minus pi. Omega naught t plus minus pi. So cos theta plus minus pi is equals to minus cos theta. So this has become minus a1 cos omega naught t, right? You can write down this calculation in rough work somewhere. Here I am directly replacing minus a1 cos omega naught t. Here what will happen? Cos 2 omega naught t plus minus t by 2. So cos 2 omega naught t plus minus 2 omega naught t by 2. So what it will become? Cos 2 omega naught t plus minus, what is omega naught t? That is 2 pi. So cos 2 omega naught t plus minus 2 pi will be equals to cos 2 omega naught t only. So here positive sign only will come out. Basically it will be same as it is. Ditto same as it is. A2 cos 2 omega naught t. In 3 omega naught t, so whatever that is odd, their negative sign is coming out. And whatever that is even, odd means odd harmonic. 3, 1, negative sign is coming out. 2, positive sign will come out. Okay, same goes for cosinusoid as well, because both of the things were similar for sinusoid and cosinusoid. Theta plus minus pi, theta plus minus pi, theta plus minus 2 pi, theta plus minus 2 pi. So both were same for sinusoid and cosinusoid. If negative sign is coming out in sine, then in cos as well negative sign is coming out. If positive sign is coming out in sine, then in cos as well positive sign is coming out. So similarly here, what is the frequency? 1 omega naught. 1 omega naught. So negative sign is coming out. 2 omega naught, no negative sign is coming out. 3 omega naught, negative sign is coming out. What I need to do? I need to place x of t is equals to minus of x of t plus minus t by 2. What does that mean? That c naught has to be equals to minus c naught. So from there, c naught is coming out to be 0. What about this one? A1 cos omega naught t should be equals to negative of this one. Negative of this one. A1 cos omega naught t, which is pretty obvious only. Similarly, A3 cos 3 omega naught t should be equals to negative of this one, which is pretty obvious only. A3 cos 3 omega naught t. Similarly, B1 sin omega naught t should be equals to negative of this one. B1 sin omega naught t should be equals to B1 sin omega naught t. B3 sin 3 omega naught t should be equals to B3 sin 3 omega naught t. Which are pretty obvious only, which are always true. That means omega naught frequency, 3 omega naught frequency, 5 omega naught frequency, 7 omega naught frequency will be there. Here I am not commenting on AN and BN. Here I am not commenting on AN and BN. But what I am commenting on the frequency. That means omega naught, 3 omega naught, 5 omega naught, 7 omega naught. These frequencies will surely be there. But what about this one? A2 cos 2 omega naught t should be equals to the negative of cos 2 omega naught t. And these kind of things we have seen here. This will come here and A2 will become 0. Similarly, your A4 will also become 0. Similarly, A6 will also become 0. And same goes for B2 will become 0, B4 and B6 will also become 0. So what are you understanding from here? That your xt will look something like this. That our DC is also 0, DC is also gone. So the conclusion from here is all these are gone. DC is gone, DC is gone, but omega naught frequency is there. 3 omega naught frequency is there. 5 omega naught frequency is there. and similarly goes for sinusoids as well, that your omega naught frequency is there, your 3 omega naught frequency is there, and your 5 omega naught frequency is also there. So what all are 0? DC is 0, A2, B2, A4, B4, A6, B6, A8, B8. All these are equals to 0. So these two conclusions we have made for half wave symmetry. Is that clear to you or not? So what is the meaning of half wave symmetry? The meaning of half wave symmetry is, I cannot comment on AN and BN, but certainly only odd harmonics are present. What I am saying, odd harmonics are present. What is this? First harmonic. This is your first harmonic. What is this? Third harmonic. What is this? Fifth harmonic. So only odd harmonics are present. So half wave symmetry means, that's why it is known as odd half wave symmetry. In odd, sinusoids are present. In even signal, cosinusoids are present. So if I call it odd half wave symmetry, then it will be easy for me to remember. If I call it odd half wave symmetry, then it would be easy for me to remember that only odd components will be present. So that's why they call it odd half wave symmetry. So kind of you can remember that there will be a negative sign. If there something negative is coming out to be, that means it is somewhat like odd. Although odd half wave symmetry has, or this half wave symmetry has no relation with odd signal, no relation with odd signal. But this is just to remember the harmonics, that like once you study in longer run, like let's just say you don't revise signal system for 1 month or 2 months, then you will be thinking, sir, half wave symmetry is there, then odd harmonics will be present or even harmonics will be present. So how will you remember? What is the meaning of odd harmonics? Shift and then take the mirror image. That means negative sign will be coming out. Negative sign means somewhat like odd. That means odd harmonics will be present. So in that manner you can remember. This is just a way to remember. Otherwise the name is half wave symmetry. There is nothing called odd. There is nothing called odd half wave symmetry. The name only is half wave symmetry. And half wave symmetry has nothing to do with even signal or odd signal. Even signal property is different, odd signal property is different, half wave symmetry is different. But if you call it odd half wave symmetry, the negative sign, that means odd harmonics will be present. So what I am saying, half wave symmetry means odd harmonics will be non-zero and even harmonics will be 0. Well and good, right? Then quarter wave symmetry. Okay, yeah. Formula. So I can tell you the derivation, but after the derivation, the same result will come. Can you try to do it on your own? What you will do? How will you do it? That an is 2 by t naught, forget about this 2 by t naught, minus t naught by 2 to 0 xt cos n omega naught t dot dt plus t naught by 2 to 0 xt cos n omega naught t dt. Okay, keep this as a, sorry, here it would be 0 to t naught by 2, 0 to t naught by 2. Okay, keep this as it is. Here in this one, replace t with t plus t naught by 2. So what will happen? This will become x of t plus t naught by 2. What this will become? Cos n omega naught t plus t naught by 2, and t is replaced with t plus t naught by 2. So dt will be replaced with dt only. So this will be dt only. Where will the limit change? So if t is minus t naught by 2, if t is minus t naught by 2, so the limit minus t naught by 2 plus t naught by 2, limit will go from 0 to, put t equals to 0 here, put t equals to 0 here. So limit will go from 0 to t naught by 2. Is this clear to you or not? I am replacing t with t plus t naught by 2. So if I put the lower limit here, if I put this lower limit here, then this lower limit will become 0. If I put the higher limit here, this is becoming 0 to t naught by 2. So this has gone from 0 to t naught by 2. Is this clear to you? All good? Everything is crystal clear? Now what this will come out to be? This will come out to be as cos n omega naught t just a second, 0 to t naught by 2 it has gone. Yeah, so what this will come out to be, x t plus t naught by 2. If it is half wave symmetry, then x t plus t naught by 2 is equals to minus xt. So this will come out to be as minus xt. And what this will come out to be, this will come out to be as cos n omega naught t, but with the negative sign. Basically here pi will become, if pi is becoming, then another negative sign would be there, so negative negative will make it positive. So 0 to t naught by 2 xt cos n omega naught t dot dt plus 0 to t naught by 2 xt cos n omega naught t dot dt. So again you are getting the same formula that we have got here, Bn formula and An formula. So in that manner you can derive. Basically derivation step I have told you that in place of t you need to put t plus t naught by 2. Okay, and here you will realize that if n is even, then your whole integration is coming out to be 0. This whole integration is coming out to be 0. Basically if n is even, then negative sign will come out. So if negative sign is coming out, so negative negative will get cancelled, negative positive will get cancelled out, answer would be 0. And if n is odd, then positive sign will be coming out. If n is odd, then positive sign cycle will be coming out, positive sign will be coming out, then both will be added. So An formula and Bn formula you will get. So what will be the formula that you will be getting? The same formula that we have written previously. So formula will be An equals to 4 by t naught, taking the window of t naught by 2, xt cos n omega naught t dt, with a always c comes, and Bn equals to 2 divided by actually this window, 2 divided by this window which is t naught by 2. So this goes upward, so it becomes 4 t naught, 4 by t naught xt sin n omega naught t. But these formula are only valid for n equals to odd, valid for n is equals to odd, and they are equals to An is equals to Bn is equals to 0 when n is even. Is that clear to you? Okay, let's see the quarter wave symmetry. So what is the meaning of quarter wave symmetry? That it has to be even as well, it has to be half wave symmetric as well, or it has to be odd as well, or it has to be half wave symmetry as well. Basically odd plus half wave symmetry or even plus half wave symmetry. This condition should be satisfied. X of minus t is equals to x of t, or x of t plus minus t by 2 is equals to minus of xt. If these two are satisfied, then also quarter wave symmetry, or if these two are satisfied, negative sign, then also quarter wave symmetry. So if these two are satisfied, so if it is even, what does that mean? Even means Bn is 0. I am only writing which is surely 0. So even means, what is the meaning of even? Even says that Bn will be surely 0. I am not sure about C naught value, I am not sure about An value, but if it is even, then surely Bn is 0. Say yes or no. And what is the meaning of half wave symmetry? If half wave symmetry is there, that means C naught is certainly 0. If half wave symmetry is there, that means C naught is certainly 0, and n equals to even is also 0. If n is even, that also is 0. What does that mean? That your xt would be no DC value. If half wave symmetry is also there and even is also there, that means no DC value. No DC value. Are you getting this point? There would be no DC value for sure. Now, if it is even, that means there will be no sinusoids as well. So only cosinusoid will be there. Only cosinusoid will be there. But if it is half wave symmetry, that means only omega naught, 3 omega naught, 5 omega naught, and in that manner only odd harmonics will be present. That means cosinusoid would be present, but only odd harmonics. Is that clear to you or not? So better than remembering quarter wave symmetry, remember this particular thing. There you go. This is the formula for xt. Are you able to understand this point or not? Even means sinusoids are gone. Half wave symmetry, DC is gone. Along with that, along with DC, 2 omega naught, 4 omega naught, 6 omega naught, all these are also gone. Say yes or no. So here, better than writing n equals to even, I should write omega naught, sorry, 2 omega naught, 4 omega naught, 6 omega naught, all these are also 0, right? Well and good. So this is your xt. Now here, what would be the formula of an? So formula for an, here also it was 4 by t naught by 2 xt cosine omega naught t, and here also it was this formula. Okay. So when we manipulate the derivation and all these things, if there is quarter wave symmetry, so first what we did, we took the window for t naught, right, in the normal formula of an, then when we saw even symmetry, we broke down the window in t naught by 2. When we saw half wave symmetry, we broke down the window in t naught by 2. Now if half wave symmetry and even symmetry both are together there, then we will break down the window in t naught by 4. So what I am doing now, breaking down the window in t naught by 4, xt cos n omega naught t dt. So this comes after the derivation. Here what do we write? 2 divided by the time window. So this 4 goes upward, so it will become 8 by t naught. Although it will be very rare chance that you will have to use this formula anywhere. What I am saying, very rarely you will have to use this formula, but if you can remember, you can remember it. And we will write down the conclusion, everything will be clear. As of now, you feel like that, sir, there are a lot of things, but there are not a lot of things. I can tell the conclusion just here only. Even symmetry, Bn is 0. Odd symmetry, DC value is 0 and An is 0. Half wave symmetry, in half wave symmetry, DC value is 0 and 2 omega naught, 4 omega naught, 6 omega naught, all these are 0. That's it. This is the conclusion. Formula if we write down, in even, if I write down the formula of An, then usual formula would be taking the window of t naught, but here I can take the half window. So if I take the window of t naught by 2, then here what will come? 2 divided by the window, 2 divided by t naught by 2. So that will become 4 by t naught xt cos and omega naught t. Same goes for odd as well, same goes for half wave symmetry as well. But if two things are together available, then first I broke down the window from t naught to t naught by 2. If two things are available, then I can break the window from t naught by 2 to t naught by 4 as well. So now I will take the window of t naught by 4 only and I will do this calculation. Is that clear to you or not? What could be the second way? This could be the second way, right? Let's write down in a better handwriting that it could be odd or it could be half wave symmetric. Sorry, both should be there, then only you will call it quarter wave symmetry, right? So what is the meaning of odd? Here, how did we write down? What is the meaning of odd? That means cosinusoid should not be present. This is the meaning of odd. Along with that, odd says that DC should also be 0. What half wave symmetry says? Half wave symmetry also says that DC should be 0. Along with that, half wave symmetry says that omega naught, not omega naught, 2 omega naught, 4 omega naught, 6 omega naught, all these should also be 0. What does that mean? Your xt would be, DC is not there. Now, sinusoids are present, but only for omega naught, 3 omega naught, 5 omega naught and 7 omega naught. So, B1 sin omega naught t plus B3 sin 3 omega naught t plus B5 sin 5 omega naught t and so on. In the similar manner, here as well, what is the scene? Here also, the Bn formula can be broken down with the window of t naught by 4, xt sin n omega naught t. Basically, here we wrote down this formula, no? Here we wrote down this formula, breaking down into t naught by 2. So here it can be broken into t naught by 4. Okay, here it was broken into t naught by 2. So here odd and half wave symmetry both are there, then it is known as quarter wave symmetry. So from quarter you will understand t naught by 4. So I can break it down into t naught by 4. Okay, t naught by 4 window, and 2 divided by t naught by 4, that means 8 divided by t naught xt sin n omega naught t dt. This is the formula of Bn. So that's it about the complete symmetricity. Nothing else is there. This topic seems very tough to the students because the flow is not clear. But here our flow was pretty good. First we understood about the symmetricity and then we saw the effect of those symmetricity, and which is very simple. Say yes or no. So we can write down the conclusion now, but before that we can write down the formula that this was the formula of C naught. What was the formula of Cn? This was the formula of Cn. Like it feels like that there are a lot of formula, but these are not a lot formula, right? You can remember it. Xt e to the power minus j n omega naught t dt. Take the window for t naught. So this was the formula for Cn. Then an formula, this was the general formula. But if it is even, or if it is half wave symmetry, then this formula I can write down, which can be broken into t naught by 2, here 4 divided by t naught, or you can say 2 divided by this window, xt cos n omega naught t dt, right? And if even plus half wave symmetry is there, then this formula can be broken into 8 divided by t naught, or you can say 2 divided by this window, xt cos n omega naught t dt, and same goes for Bn as well. So just in one page I have seen that like there are a lot of formulas, but I can conclude in this manner. And believe me guys, there would be 1% chance that you will ever have to use these kind of formula in the examination hall. In the examination hall, rarely you will have to use this formula, okay? Rarely, very rarely. All good? So just in statement wise they can ask these kind of questions that your function is even and it is having half wave symmetry as well. So what could be the formula of an? So this is the general formula which always works. This can also work and this can also work. Basically if it is even, then this formula can certainly work. If it is half wave symmetry, then also this formula can work. This is the general formula that can always work, and this can also work. But if someone writes down t naught by 8, then 16 by t naught, this doesn't work. Like there is no formula like this. So that's why I have written down this formula, that if in statement wise, in options, if they are asking these kind of questions, then you will be able to answer it. Conclusion: if the graph is even, it could be 0 or non-zero. If graph is odd, it has to be 0, and if graph is half wave symmetry, it has to be 0. If graph is even, this has to be 0. If graph is odd, this has to be 0. If graph is half wave symmetry, then half wave symmetry means 2 omega naught, 4 omega naught, 6 omega naught, all these have to be 0. What is the formula of an? That would be 4 by t naught, because since it is even, then I can break down the window in t naught by 2, xt cos n omega naught t dt. And if it is odd, then also I can break down the window, xt sin n omega naught t dt, right? Window is t naught by 2. And if it is half wave symmetry, then this formula will be there for both of them. Just the important part is that it will be there only for n equals to even, right? Same goes here as well. This will be only there for even frequency. N equals to even means, really sorry. This will be there for n equals to odd, because for n equals to even, this will be equals to 0 only. So this will be there only for n equals to odd. That means for odd harmonic only it will be there. Omega naught t, 3 omega naught t, 5 omega naught t, right? So xt sin n omega naught t dt. So again and again I am writing conclusion so that you don't feel like that, sir, there are a lot of formula, there is a lot of pressure. No, there is not a lot of pressure. If you are studying from PrepFusion, then you will never ever have to mug up the formula or any method. Never ever mug it up. Okay, we will build the problem solving skills, we will build the concept, and these two things are very much necessary for cracking any examination, and these two things are enough for cracking any examination, right? Now we have to see some questions, but before that we need to see a simple concept. If I subtract the DC value from xt, then what will happen? Basically this DC value goes here, so xt minus c naught. So xt minus c naught will have the Fourier series coefficient of these things. Basically what I mean to say is that Fourier series coefficient will not change. What I mean to say, this is my xt, this is c naught a1 cos omega naught t. I'm thinking that everything is non-zero, everything is non-zero, like everything is existing. A2 cos 2 omega naught t, all these will exist. Along with that, b1 sin omega naught t plus b2 sin 2 omega naught t, all these will exist. This is what I am thinking, right? If I subtract x t minus c naught, so from here also c naught will be subtracted, that means this DC part will be gone. Or let's just say if I subtract a random value xt minus, I am subtracting a random alpha 1 value, constant, this is a constant, okay, I am subtracting a random constant. So what will happen? The DC value will become c naught minus alpha 1, but these coefficient will not change, these will remain there as it is. So no change is done in an and bn. If you are subtracting any random constant value, no changes are done in an and bn. That means all these remains as it is, all these remain as it is. What does that mean? No changes, no changes in an and bn. Kind of I can say that if your xt is having, if your xt is having DC of c naught, an and bn, then your xt minus alpha will have DC of c naught minus alpha, DC of c naught minus alpha, and the same an and bn. Is this concept clear to you? Right? Very simple. Because in some questions I will be subtracting the DC part to get the symmetry, right? It might happen that the graph looks like neither even nor odd, but if I subtract the DC part, I will get odd halfway, odd symmetry, or I can get halfway symmetry as well, or I can get even symmetry, anything I can get. So DC value subtraction is a very good tool which I can use, right? Let's see a question. Fundamental frequency of xt is omega naught, yt is equals to xt minus 2, yt has trigonometric Fourier series coefficient a1 equals to 2, a3 equals to 1, b1 equals to 2. Yt has a 0 DC value. Find the trigonometric Fourier series for xt. What I mean to say is that yt equals to xt minus 2. DC value is 0. DC value is 0. DC value is 0. DC value is 0. So no DC value. Then a1 is non-zero. Plus a3 is non-zero. A3 is non-zero. Then b1 is non-zero. b1 is non-zero. b1 means sinusoid of omega naught frequency, a3 means cosinusoid of 3 omega naught frequency, and a2 means, sorry, a1 means cosinusoid of omega naught frequency. So this is your yt. So from here what will be your xt? Xt will be 2 plus 2 cos omega naught t plus cos 3 omega naught t plus 2 sin omega naught t. So if fundamental frequency of xt was omega naught, so fundamental frequency of yt was also omega naught. Here also fundamental frequency, here also fundamental frequency was same, because subtracting a DC value will not change the fundamental frequency, right? Just the only difference is here c naught became 2, rest all things are same only. A1 is 2, A3 is 1, and B1 is 2. So whatever things that I have proved here, the DC value just got changed, nothing else got, rest all the things remain same, right? Now we need to see some questions. We need to find an and bn value, and then we will see what kind of symmetry is there. All these kind of things we will see. Okay, so I will take a pause and then I will come back. We will solve this kind of question. One question is there, then 2, 3, 4, 5. So 5 questions are there. When we solve these 5 questions, all your concept will be clear. Okay, so let me take a pause and then I will come back. Till then you try solving these questions on your own. Thank you very much. Yeah, welcome back. So did you try this question? So when I see this graph, first thing what I will see, average value. C naught value. This is the first thing that I will always calculate whenever I need to find an and bn. I will always calculate the dc value. Dc time period, I can see it is t only, right? Minus t by 4 to 3t by 4. In this window it is being repeated. So time period is t. I need to find the dc value. Dc value is a into the area of this will be a into t by 2 divided by the time period. So dc value is a by 2. DC value is non-zero. My target would be to make DC value equals to 0. There you go. So what will be my target? Target is making the DC value equals to 0. That means I need to subtract a by 2 from this particular waveform. So if I subtract a by 2 from this particular waveform, that means 0 will go to minus a by 2 and a will go to plus a by 2. So this kind of waveform we will get. Very simple thing. I need to subtract a DC value a by 2 from this. So a will go to a by 2 and 0 will go to minus a by 2. This is your yt. Well and good. So what kind of graph is that? Even. This graph is even. This I can already see. Can I pick this window of t time? Here, this graph is even, that's for sure. Can I pick this window of time t? Yes. Another thing I can see is that this window is t by 2. So if I shift this waveform and then take the mirror image, then am I getting the mirror image of this? Basically, are the graphs superimposed? Basically, shift by t by 2 and then take the mirror image. So graphs will be superimposed. Or what I can do? This is t by 4. This is 3t by 4. So this will be t by 2. Now what is the value at t equals to 0 plus? Since I can apply this particular method because DC value is 0 here. So x at t equals to 0 plus is a by 2 and the value of xt at t equals to t by 2 plus is minus a by 2. So from here I can say that it is half wave symmetric as well. So it is even and half wave symmetric. What does that mean? That bn will be 0 and a2, a4, a6, all these also will also be 0. But what I need to find? I need to find the value of an. I need to find the value of an. So let's find out the value of an. Now here it is having even plus half wave symmetric. What does that mean? It is quarter wave symmetric. And if it is quarter wave symmetric, then t naught by 2, t naught by 4. So I can break the window as t naught by 4. And here what I will write? 2 divided by the window. xt cos n omega naught t dt. What is the time period? Time period is t. What is the time period? Time period is t. And what is the omega naught? Omega naught is 2 pi by t, right? So I will keep omega naught as omega naught only. Basically here I am taking the time period as t only. So omega naught is also omega naught only, right? And if I am writing t naught by 4 here, so let's write down t by 4 because time period is t, not t naught. So I am taking the window to be t by 4. So what I am doing? An is equals to 8 by t. Window I can take, I need to take a window of t by 4. So can I take from 0 to t by 4? 0 to t by 4, this window I am taking. I need to take a window of t by 4. I can take from minus t by 4 to 0 as well. I can take from 0 to t by 4 as well. Or I can take from t by 4 to t by 2 as well. But I am taking from 0 to t by 4. 0 to t by 4. What is the value of xt in that? A by 2. A by 2. Cos n omega naught t dt. So what we are getting? 4a by t. 4a by t sin n omega naught t divided by n omega naught 0 to t by 4. So 4a by n omega naught t sin n omega naught t by 4 minus sin 0, sin n 0. So sin 0 will be 0. What is omega naught into t? Omega naught t into t is 2 pi. So here I will put 2 pi by 4. So what I am getting? Here what I will get? Omega naught into t. What is omega naught into t? That is 2n pi. Here what I am getting? Sin omega naught into t is 2 pi by 4. So sin n pi by 2 minus sin 0 is 0 only. So what answer I am getting? 2a by n pi into sine n pi by 2 into sine n pi by 2. This is the value of your an. From here you can directly see, from here what you can see, from here you can directly see that what will be the value of a1? a1 will be 2a by pi. What will be the value of a2? If you put 2 here, sin pi would be 0. What will be the value of a3? If you put 3 here, what you will be getting? 2a by 3 pi sin 3 pi by 2. Sin 3 pi by 2 is minus 1. So minus sign. What will be the value of a4? If you put 4 here, sin 2 pi would be 0. So a4 would be 0. What will be the value of a5? If you put 5 here, sin pi by 2, sin 5 pi by 2 is positive. So what you will be getting? 2a by 5 pi. 2a by 5 pi. a6 will be 0. a7 will be, what will be a7? That would be minus 2a by 7 pi. In that manner we are going, right? So what I can see is that I have to add a page. I have to add a page. So my xt is given as, now I am talking about xt minus a by 2. What I am talking about? I am talking about yt. All these things I have find out for yt. All these things I have find out for yt. And what is your yt? Yt is xt minus a by 2. And that is equals to, it is having a1 as 2a by pi. 2a by pi cos omega naught t. Plus, next part will be 0, right? Basically, 2 omega naught t will be 0, a2 will be 0, next part will be minus 2a by 3 pi. Next part will be minus 2a by 3 pi cos 3 omega naught t. After that what will become? 2a by 5 pi cos 5 omega naught t. 5 omega naught t. After that minus 2a by 7 pi. Basically 2a by pi minus 2a by 3 pi, 2a by 5 pi minus 2a by 7 pi. So pi, 3 pi, 5 pi, then 7 pi. Plus minus plus minus. So the cycle is clear to you, right? And there you go. This is how it will keep on proceeding. So this is your xt minus a by 2. So what is your xt? So if you go here, if you see xt, this was your xt. So xt is having a dc value of a by 2. So this a by 2 can go here, dc value of a by 2. xt is having a dc value of a by 2. xt is having a dc value of a by 2. Then you go to know that it is even, and also it is having half wave symmetry as well. Although yt is having half wave symmetry, but it would be same for your xt as well. So half wave symmetry and even is also there. Even means no cosinusoid, no sinusoid would be there. So only cosinusoid would be there. And if half wave symmetry is there, that means it will have omega naught, 3 omega naught, 5 omega naught. And what is the amplitude that we have found out? Amplitude is coming out to be 2a by pi cos omega naught t minus 2a by 3 pi cos 3 omega naught t, then 2a by 5 pi cos 5 omega naught t, then 2a by 7 pi cos 7 omega naught t. In that manner it will keep on going. Okay, so this is your xt. If you can, you should remember the answer. What I am saying, if you can, then try remembering the answer. What you need to remember, as an electrical student, if you are someone from electrical, then in power electronics you will be using this waveform again and again. I am talking about electrical students, okay? And if you want to be an analog engineer in future, like a design engineer if you want to be, so when you go to industry you will use this waveform a lot of time. Basically this waveform or this waveform. Square wave is used a lot of time. Square wave is used in a lot of circuits. Everywhere square wave would be there. So you should know what will be the frequency component. If you see this waveform, you will get to know that, sir, certainly it will have omega naught, 3 omega naught, 5 omega naught. These frequency component it will have, and those component will be cosinusoid. Now if someone is asking you that what is the amplitude, so the amplitude will be 2 into peak to peak divided by n pi. I am talking about the magnitude. Here negative sign is there. I know negative sign is there. But what I am saying, 2 into peak to peak divided by n pi. So if someone is asking you, what is the amplitude of first harmonic? What is the amplitude of first harmonic? So what you will do? 2 into peak to peak, a by 2 minus a by 2. What is the peak value? Peak to peak value is a. Or you can see in this, what is the peak to peak value? Peak to peak value is a. What if this was plus a? Let's just say if this was plus a and this was minus a. So what would have been the peak to peak? Peak to peak would have been 2a, right? So if they are asking you what is the magnitude of first harmonic, so that would be 2 into peak to peak. Peak to peak is a by 2 to minus a by 2. So that would be 2a by first harmonic, that means n equals to 1. So magnitude will be 2a by pi. If they ask you the magnitude of second harmonic, then you will say that, sir, it is half wave symmetric. What is this, sir? Sir, it is having half wave symmetry. What does that mean? That it will not have even harmonics. It will only have odd harmonics, omega naught, 3 omega naught. So if someone is asking you what is the amplitude of second harmonic, your answer would be 0. What is the amplitude of third harmonic? 2 into peak to peak divided by n pi. Although there is a negative sign, but they are asking the magnitude only. So if you want to remember, you can remember, but it is not a it is not a compulsion. But as an analog engineer, at least for square wave, I will remember the answer. That my amplitude is 2a by n pi. What I remember, 2 peak to peak n pi. And then I would know that it will only have omega naught, 3 omega naught, 5 omega naught, and so on. If someone is asking me second harmonic, so second harmonic I already know it would be 0. Fourth harmonic, I already know it would be 0. If someone asks me seventh harmonic, so what I will say, 2 peak to peak, 7 pi. This will be the magnitude, and cos 7 omega naught t. Here plus sign could be there, minus sign could be there, that I don't care. I am only talking about amplitude. Okay. So when I teach placement, guys, those who are preparing for placement, then there also I teach all these things, and then we frame some question as well. Although these questions we will take after Fourier series. Not after Fourier series, after Fourier transform, those kind of questions also I will take. Some good questions I will take. Okay, no need to worry. So you see this question, filter based question. Basically here also I frame filter based question, that if this particular waveform is passed through, a low pass filter of that particular cutoff frequency, then what will be the output waveform? These kind of questions. But these kind of questions usually I teach to placement guys, those who prepare for VLSI placement, MTech, BTech students. In GATE as well I will deal these kind of questions, but after the Fourier transform. Okay. Although a small trailer I am already giving here. Here, which frequency components are present? That I am asking. Then I am asking you, if xt is passed through a low pass filter of 100 millihertz cutoff frequency, then draw the output waveform. What is a low pass filter? What is the meaning of low pass filter? So first let me tell you what is low pass filter. Low pass filter having cutoff frequency is shown by fc, having cutoff frequency of 100 millihertz. 100 millihertz means 0.1 hertz. Okay. So what does that mean? That it will pass all the frequencies. It will pass all the frequencies which is there between 0 to 0.1. Are you getting this point? Low pass filter. That means it will pass the frequency which is lesser than 0.1 hertz. The frequencies which are lesser than 0.1 hertz, that will be passed. Basically this is xt. What is this? This is the input, this is the output. Let's just say input is having a frequency of 0.01 hertz and 10 hertz and 0.05 hertz and 200 hertz. So at the output what you will get? 10 hertz will not pass because it will pass only till 0.1 hertz, and here also you can write down minus 0.1 hertz. So at output you will not have this, and output you will not have this. At the output you will only have these two, 0.01 and 0.05. Is that clear to you? Okay. And magnitude they did not mention, so I will take the magnitude to be 1 only. Basically there will be no amplification. If I pass xt from here, then at the output as well I am getting xt only with the certain frequency component. Okay, so no amplitude is there. Let's just say if it was 5, so here amplitude have been 5 times. Are you getting this point? So I am assuming the amplitude is 1 only, so no amplification is there, no attenuation is there. Directly whatever the frequency component are there in the input, some part of frequency component will be passed. So what I need to understand, that what all frequency component are present in this particular waveform. So first thing, I can directly see that my DC value is not 0 here. One good point I can see here is that my DC value is not 0. So what is the DC value here? First you see the time period. First you let me know the time period. This is the time period, right? Minus 2 to 4. So the time period is 6. What will be the DC value? DC value will be 1 by 2. Addition of parallel side. Addition of the length of the parallel side. So this is the parallel side. That is, oh, let's solve by triangle only. Let's solve by triangle. So here you can see one triangle. 1 by 2 into base into height. Half. Another triangle you can see. Half plus half 1. Plus then you see this rectangle. Plus 2. So this is the area divided by the time period. So DC value is 2. Basically C naught value is 1 by 2. C naught value is 1 by 2. So what you need to do? You need to subtract 1 by 2 from this waveform. So what will happen? 1 will go to 1 by 2. This 0 will go to minus 1 by 2. Right? So what kind of waveform we will get? So we will get this kind of waveform. So it was 0 between minus 2 to minus 4. So it will be minus a by 2. Between minus 2 to minus 4. Minus 2 to minus 2 to minus 4. Right? Now this was the transition period. This was the transition period between minus 2 to minus 1. So this is the transition period. Oh, minus 4 to minus 2. Really sorry. Minus 4 to minus 2. Transition period is between minus 2 to minus 1. Then there is 0. Here where is the transition period? Transition period is between 1 to 2. So transition period is between 1 to 2. Then between 2 to 4 it was 0. Now it will become minus 1 by 2. It will become minus 1 by 2. This is plus 1 by 2. This is minus 1 by 2. Plus 1 by 2. Minus 1 by 2. So between 2 to 4 it will become minus 1 by 2. Then here transition period was between 4 to 5. So transition period would be between 4 to 5. Right? Transition period will be between minus 4 to minus 5. Right? Xt minus 1 by 2. So this I have made for xt minus 1 by 2. I can directly see that this waveform, in this waveform I can mark down the time window. Basically time period I can mark down. So time period is 6, right? Time period is 6. So between minus 2 to 4, this is the time period. This is the time window t. Right? This waveform is being repeated. This waveform is being repeated. So time period is this t. Right? Or I can see that this window and this window I can take. Basically this window could be t by 2 and this window could be another t by 2. So what I can see is that if I take this graph, and then I shift it here and then I take the mirror image, take this much portion, shift and then take the mirror image, what do you see? Half wave symmetry is there, right? Or what you can see, since DC value is 0, so what is the value at x equals to 0 plus? What is the value at x equals to 0 plus? That is half. And what is the value at t by 2 plus? So let's mark t by 2. What is the value of t? Value of t is 6. Value of t is 6. So what will be t by 2 plus? That will be 3 plus. So here there is 3. So t by 2 plus is minus 1 by 2. So from here what do you see? Half wave symmetry is there. So it is even as well. Directly we can see it is even. Along with that it is having half wave symmetry as well. So it is having half wave symmetry and it is even. That means only cosinusoid component would be present. Along with that, what all frequency component are present? So what will be the answer of A? Frequency component would be omega naught, 3 omega naught, 5 omega naught. Why is that so? Why is that so? Because there is half wave symmetry. If there is half wave symmetry, what is the meaning of half wave symmetry? The meaning of half wave symmetry is that it will not have even components, it will only have odd components. That is clear to you? I hope you remember this, right? You need to remember this. Half wave symmetry means, half wave symmetry is same as odd half wave symmetry. Odd means only odd components it will have. So omega naught, 3 omega naught, 5 omega naught. But the cutoff frequency is given in hertz. So this is in f. So it is having omega naught, 3 omega naught, 5 omega naught. So can I write down that it will have omega naught, sorry, f naught, 5 f naught, sorry, 3 f naught, 5 f naught. So basically your xt is having f naught, 3 f naught, 5 f naught, and so on. What is the value of f naught? F naught is given as 1 by t naught. What is the value of t naught? 6. So f naught is 1 by 6, that is 0.167 hertz. Are you getting this point? F naught is 1 by t naught. What is the value of t naught? What is the value of t naught? T naught is 6. So 1 by 6, that means f naught is 0.167 hertz. Are you getting this point? So in this xt waveform, what all things you are having? In the xt waveform, what all things you are having? In the xt, there is dc. What is the value of dc? Half. In xt, you are having dc. Along with that, I don't care about the amplitude. But I am having cos omega naught t plus cos 3 omega naught t and so on. So this is having a frequency component of 0.167 hertz. This is having a frequency component of 3 into 0.167 hertz. This is having a frequency component of 5 into 0.167 hertz. And what is the frequency component of this DC? That is 0 hertz. You will say that, sir, in this waveform you get even plus half wave symmetry. So if this waveform is having even plus half wave symmetry, then you can say that the same components this waveform will have. Only DC will be different. Here the DC is 0, but here the DC is half. So what I can write down? This is having DC of half and all these components. That means it is having a frequency component of 0.167 hertz, 3 into 0.167 hertz, 5 into 0.167 hertz, 7 into 0.167 hertz. Along with that, it is having a frequency component of 0 hertz as well, right? And now it is passed through a low pass filter. A low pass filter which passes only frequencies less than 0.1 hertz. So which component it will pass? This low pass filter passes only frequencies which are less than 0.1 hertz. So which frequency component it will pass? 0.167 hertz, it will not pass. 3 into 0.167 hertz, it will not pass. After that, it will not pass anything. It will only pass DC. So at the output, what you will receive? So what will be the waveform of output? Only the DC. What will be the waveform of output? So this will be your output waveform. Okay, output is a function of t, you can say, although it is not a function of t. Output is simply a DC. What is output? Output is simply a DC of 1 by 2. So this is the output waveform. Okay, well and good. Did you understand this point? Now let's just say if my cutoff frequency was 0.2 hertz. What I am saying? If my cutoff frequency was 0.2 hertz. So can you predict the nature of output? If your cutoff frequency was 0.2 hertz, then A1 cos omega naught t will pass plus DC value will pass. So one thing I know that this will be my output. And what is this? This is cosinusoid. Cosinusoid but shifted upward. I don't know the value of A1. But the nature will be cosinusoid shifted upward. So this kind of waveform I will get. This is your cosinusoid. But shifted upward. Shifted upward means something like this. Cosinusoid shifted upward by half. So peak value will be A1 plus half and this value will be minus A1 plus half. Say yes or no. Are you able to understand all these points? If your cutoff frequency was 0.2 hertz, that means it will pass frequencies lesser than 0.2 hertz. That means it will pass DC as well, it will pass cosinusoid as well. So output waveform would have been cosinusoid plus DC. That means cosinusoid shifted upward by DC, this would have been your output waveform. You don't care about the value of A1. If you care about the value of A1, then you can calculate. From here, you can calculate because it is having quarter wave symmetry. So you can calculate the value of A1, but no one will ask you all these things. Okay, no one will ask you the value of A1. In the good interview, they will ask these kind of questions that this is a particular waveform. It is passed through a particular low pass filter having a particular cutoff frequency, then predict the nature of the output waveform. They can put any kind of cutoff frequency. You need to see that what all frequency component this guy is having. Okay, what all frequency component this is having. So this is having frequency component of f0, 3f0, 5f0 and so on. Along with that, it is having a DC as well. So based on the cutoff frequency of this one, only DC value was passing. So this was the waveform. If cutoff frequency was this one, then DC value along with that cosinusoid will also pass. So output will be cosinusoid shifted upward by the DC value. Okay, there is something called band pass filter as well. Okay, there is something called band pass filter. What is the meaning of band pass filter? That it passes a particular band only. Let's just say band pass filter is having a lower cutoff frequency of 0.1 Hz and higher cutoff frequency of 0.2 Hz. What does that mean? That it will pass all the frequency ranges between 0.1 to 0.2. Whatever the frequency is there between 0.1 to 0.2, it will pass only that frequency. So will it pass DC? DC means zero frequency. So it will not pass DC. Will it pass this one? Yes, it will pass this one. Will it pass this one? No. Will it pass this one? No. So it will only pass between 0.1 to 0.2. That means it will only pass cosinusoid. So the nature of output will be cosinusoid. So these kind of questions can be asked in a very good interview, and till now these kind of questions are not introduced in the gate examination. Hopefully it will be introduced. But once you go to IITs and then you appear for master's interview, there such questions are very common. Okay, these are considered in a very good question. Right, so here you need to use the concept of Fourier series, Fourier transform, and this is how the Fourier series and Fourier transform are used in the industry. Okay, so any particular waveform is given, you need to analyze that particular waveform, that what all frequency component this will have, and if there is some filter in my circuitry, like there could be some high pass filter, low pass filter in your circuitry, and when you pass that particular waveform from that particular circuitry, then what will be the output? Can you make the low pass filter? Yes, RC low pass filter. So it would be there in your circuitry, somewhere it would be there. So what will be the frequency component in the output? So what you did, you applied this square waveform, not square waveform, sorry, trapezoidal waveform. You applied this kind of trapezoidal waveform, then there was a low pass filter, and at the output you got DC. Are you getting this point? Well and good. Okay. Non-zero component. Tell the non-zero component in this particular waveform. DC value is already 0. What I can see? This is even. And directly I can see that it is half wave symmetric as well. How I can see? Just shift this here and then take the mirror image. Shift this much portion here and then take the mirror image. So half wave symmetry is also there. Or 0 plus, this will be t by 2, right? This value I am calling as a, and this value I am calling as minus a. So what is the value at t equals to 0 plus? That value is a. And what is the value at t by 2 plus? T by 2 plus, that is nearly minus a. So from here as well I can say that it is having half wave symmetry. So only non-zero component you need to tell. That means it will have non-zero component of, it will have cosinusoid, and those components will be f0, 3f0, 5f0, 7f0 and so on. So always you need to check the half wave symmetry, and if there is half wave symmetry, then these components will be present. Let's see this question. Is it even? Absolutely not. Is it odd? Absolutely not. We have seen this example a lot of time, right? X of 0 plus is nearly 0. X of 0 minus is minus a. So it is neither even nor odd. Neither even nor odd. What does that mean? And already DC value is 0. Already DC value is 0. So in the graph I will not do any modification. Here also DC value was 0. I did not do any modification. Here also DC value is 0. I will not do any modification. So already DC value is 0. It is neither even nor odd. What does that mean? That means that it will certainly have sinusoid and cosinusoid both. But what will be the frequency component? It will not have even frequency component. Why is that so? Shift, take the mirror image, or what you can check, 0 plus, what is the value? Nearly 0, plus 0 I can say, 0 plus it would be plus 0, and at t by 2 plus, at t by 2 plus it is minus 0. So from here what I can say, half wave symmetry is there. So only half wave symmetry is present. It is neither even no rod, it is neither even no rod, and only half wave symmetry is present. What is the DC value? DC value is 0. So xt is, what is xt? A1 cos omega naught t plus A3 cos 3 omega naught t plus A5 cos 5 omega naught t, in that manner, plus B1 sin omega naught t plus B3 sin 3 omega naught t, and so on. So it will have sinusoid and cosinusoid both. This was only having cosinusoids only. Cosinusoids only. But this will have sinusoid and cosinusoid both. Okay. And frequency would be omega naught, 3 omega naught, 5 omega naught, 7 omega naught, and so on. We don't care much about the amplitudes A1, A3, B1, B3. We don't care about that. Okay. In the examination as well, only 0.01% chances are there that you will ever have to calculate these amplitudes. But if you ever need to calculate, have we built up the method? Yes, this is how we will calculate. So I took one example where I am calculating as well. So calculation also I have shown you, and all these things, how to predict the nature of the waveform, that also I am showing you. Right? Next one, do everything on your own. Okay, very simple question it is. You need to find the value of alpha, then you need to find the power of xt using the basic concept of your basics of signal. Using the basic concept of your basics of signal, you can find out these two answer, and then you need to find out this question. Do it on your own, and then this will be the last question. So first let me take some break, and then I will come back and I will solve this question. You should be able to solve this particular question. That is my requirement. From my side, if you have been my student, if you have been following me, then from my side the requirement would be that you should be able to solve this particular question. Okay. So I will come back. You try doing it on your own. Yeah, so let's start this question. So what we need, what is given, C naught is equals to 1 by 2. That means DC value is 1 by 2. So we need to find the value of alpha. So can we calculate the DC value? Yes. What is the time period here? I can directly see the time period is 2. Time period is 2. So area divided by the time period, that will be the DC value. So what is the area? So this area you need to write down, that is 1 by 2 base into height. What is the base here? 2 alpha. Base is 2 alpha. So 1 by 2 into base into height plus whatever the area that you get here, the same area you get here as well. 2 into base. What is base? 2 into 1 by 2, because this is triangle, no? So twice into 1 by 2 into base into height. Height is minus 1 and divided by the time period. That is your C naught, right? So 2 alpha plus 2 and 2 get cancelled, alpha minus 1 divided by 2. So that is equals to 3 alpha minus 1 divided by 2. Alpha is coming out to be 1 by 3. Okay. No, alpha is coming out to be 2 by 3 actually. So 2 and 2 get cancelled. So alpha is coming out to be 2 by 3. Right? This is basic calculation. DC value is given, so you need to find the value of alpha. This should be done by you. Right? Half into base into height plus twice into half into base 1 minus alpha into height. So alpha minus 1. So 2 alpha plus alpha minus 1. So 3 alpha minus 1 divided by 2. The DC value is equals to 1 by 2. So from here alpha value is 2 by 3. So this value is coming out to be 2 by 3. Okay. Now what they are asking? They are asking the power. So power also you know. For triangular wave, I have told you some formula. What will be the power? Power will be a square by 3, a square by 3, 2 square by 3 into the width. What is the width? This width. Width is 2 alpha. 2 alpha means 4 by 3 plus a square by 3 into the width. What will be this width? this width will be 1 by 3. So a square by 3, 1 square by 3, 1 square by 3 into the width, width is 1 by 3, plus the same thing is happening here as well, a square by 3, a square by 3 into the width. So this we need to write down for a time period, then divided by the time period. So what is the time period? Time period is 2 divided by the time period. I hope you remember this formula. A square by 3 into width, we used to write down a square by 3 into alpha, then whatever the triangular waveforms are there, a square by 3, 4 by 3 into 4 by 3, 4 by 3 into 4 by 3, then 1 by 3, a square by 3 into 1 by 3. So 1 by 3 into 1 by 3, and that would be twice of that, right? So 16 by 9 plus 2 by 9 divided by 2. So 18 by 9 would be 2, 2 divided by 2, power is coming out to be 1 watt. Okay. So the power is 1. This is the answer of the second one. Power is 1. Right. This formula of power is clear to you, right? No matter whatever the triangulars are there, a square by 3 into this width, a square by 3 into this width. Here the amplitude is a, here the amplitude is b. So a square by 3 into this width, b square by 3 into this width divided by the total time period. That's it. So same thing I am doing. A square by 3 into this width, a square by 3 into this width, a square by 3 into this width divided by the total time period. So this is the method that I have already told in our basics of signals. There we talk about triangular, we talked about rectangular, and then we talked about sinusoid. So for all these three we remember the formula. For rectangular it was a square, for sinusoid it was a square by 2, and for triangular it was a square by 3 into the width divided by time period. So all these reduces our calculation, otherwise we have to write down the equation and then all these things, there would be very high chance of doing the calculation error, right? But if you have the concept clear, then calculation will also be reduced there. Next, you need to find out the frequency component. So what is the DC value here? DC value is 1 by 2. And if DC value is 1 by 2, so what will be the first task I will be doing? I will be subtracting the DC value. So xt minus 1 by 2 I need to make. Okay. So yt is equals to xt minus that DC value. What is that? 1 by 2. So 2 will go to 3 by 2 and minus 1 will go to minus 3 by 2, right? 2 will go to 3 by 2, minus 1 will go to minus 3 by 2. So the graph will be shifted downward. So this is how the graph will be shifted. This is your yt, which is equals to xt minus 1 by 2. So here we are having 3 by 2. This would be minus 3 by 2, right? So graph is shifted downward. So 1 to minus 1. This point will be 1. At 1, you are having the value to be minus 1, but this value will be now minus 3 by 2. At 1, the value will be minus 3 by 2. At minus 1, the value will be minus 3 by 2, right? This point is 0. This point is 0. What is this window? This window is time t. One thing I can see that this will be my t by 2 window, and this will also be a t by 2 window, right? So what I can see, shift and then invert, graph will be superimposed. Shift, invert, graph will be superimposed. Or what I can see, 0 plus the value is t by 2, 3 by 2, and what will be this point? Basically the time period is 2, right? So this point will be t by 2, this point will be t by 2. So what is the value at t by 2 plus? That is minus 3 by 2. So from here what you are getting? Half wave symmetry. Or shift and invert, you are getting that. If you shift and then if you invert, what you are getting? You are getting the same waveform. That means waveforms are being superimposed. What does that mean? What does that mean? That there is half wave symmetry. Along with that, you can see it is even as well. So even plus half wave symmetry is present. What does that mean? That xt is even, it is, and half wave symmetry is there. But in the xt there is a DC value, right? In the xt there is a DC value, that is half. Also, since it is even, it will only have cosinusoid, and it is having half wave symmetry. What does that mean? That it will have omega naught, 3 omega naught, 5 omega naught, and so on. So a1 cos omega naught t plus a3 cos 3 omega naught t plus a5 cos 5 omega naught t, and so on. This will be your xt. There you go. Well and good. Okay, that's it. More questions are there? No. So this was about our trigonometric Fourier series, and in this trigonometric Fourier series, what did we mainly focus on? We focused on the symmetry, even, odd, even symmetry, odd symmetry, half wave symmetry, and then quarter wave symmetry, right? And then we saw the frequency component with respect to each particular symmetry, and then we solved 5 questions on that. I hope you enjoyed the lecture. I hope you understood the concept, which seemed like a very tough concept, but it is very straightforward, very easy. If you just have the concept clear, then within 5 minutes you will be able to revise this particular video. Say yes or no. So let's meet in the next video. We have studied exponential Fourier series, but few properties of exponential Fourier series are remaining. Okay, few properties which are not important at all. So very less important properties are remaining of Fourier series. So that property we are going to see. Okay, so those basic property we are going to see, which are not very important, but I will teach you those properties just to make you learn that these are not actually important and why they are not important. Okay, you will understand when we study those property, you will understand that why they are not that important. So those property we will see, and after that some miscellaneous concept, whatever that is remaining, like Drichlet condition, Gibbs phenomena, or polar form of exponential series. So these basic concept, like 15-minute concept, these are. So these 15-minute concept also we will see in the last video. So in that manner we will proceed. Okay, so let's meet in the next video. Thank you very much. Hi everyone, welcome back. So I told you we are going to study some properties on exponential Fourier series coefficient. So till this point we have seen properties of all these exponential Fourier series coefficient, like if xt is having exponential Fourier series coefficient of Cn, then x of minus t will have C of minus n. X of at will have Cn only, but this was having fundamental frequency of omega naught. This will also have fundamental frequency of omega naught, but this will have fundamental frequency of a omega naught. X of t plus t naught will have Cn e to the power j n omega naught t naught. Fundamental frequency will also be omega naught only. X conjugate t will have C conjugate minus n fundamental frequency omega naught only. dy dt xt will have dy dt will be replaced with jn omega naught Cn, and integration will be having Cn jn omega naught, right? Fundamental frequency is omega naught only, fundamental frequency is omega naught only. So these properties we have already seen, and you need to remember the final result as well, right? Now 4 more properties are left, so we will see those properties one by one. I hope these properties are clear to you. Derivation is also clear, and the final result is also clear, and how to solve the problem based on this, that is also clear to you. Now next property we are going to learn multiplication with e to the power j m omega naught t, where m is belonging to an integer. Okay, you are multiplying your function. Let's just say this is your xt. You are multiplying this xt with e to the power j 4t. So e to the power j is something t. This is what we will multiply, and that something is m omega naught. Basically, that is the integer multiple of omega naught. So here, what is the value of omega naught? Omega naught is 2. So e to the power j 2 omega naught t. So e to the power j 2 omega naught t. This is what we have multiplied. So what will be your Fourier series coefficient? Dn. This is what we need to talk about. Okay. So xt is given. So first let's solve the problem, and then we will see the results, right? So first solve the problem the way you would have solved in the examination hall. Xt is given, you need to draw Cn versus n. So you already know what you need to do. Xt is sine 2t, where omega naught is equals to 2. So from here I know that my C1 will be 1 by 2j, and my C of minus 1 will be minus 1 by 2j. And I already know the graph of C of n versus n, because these I have drawn like a lot of times. C of n versus n. One by 2j and minus 1 by 2j. Next, what we need to do, our yt is e to the power j 4t dot xt. What is our yt? e to the power j40 dot xt. Xt means sine 2t. So how would I solve it? E to the power j40. Now I can replace sine 2t, that is e to the power j2t minus e to the power minus j2t divided by 2j. So what you are getting? E to the power j60 minus e to the power j2t divided by 2j. Here what is the value of omega naught? You can directly see here what will be the value of omega naught. That would be HCF of 2 and 6, because this is saying that my fundamental frequency is 2, this is saying my fundamental frequency is 6, and both are in multiplication. If both are, sorry, both are in addition or subtraction. So if both are in addition or subtraction, then I can take the HCF. So that would be 2. That means it is written as e to the power j 3 omega naught t divided by 2j minus e to the power j omega naught t divided by 2j. So Fourier series coefficient was dn, right? So from here what do I see? My d3 is 1 by 2j and my d of 1 is minus 1 by 2j, right? So can I draw the graph of d of n? This is the graph of d of n. D of n versus n. This is a very simple property. So d1 and d3, d1 and d3, 1 and 3. Okay, d1 was 1 by 2j. Sorry, d1 is minus 1 by 2j and d3 is plus 1 by 2j. This is plus 1 by 2j and this is minus 1 by 2j. Now if you see one thing, if you see this graph of C of n and then you see this graph of D of n, what you can see? Isn't it shifted by 2? If you shift this graph by 2 on the right hand side, what you will get? Shift this graph by 2. Shift this graph by 2. What you will get? 1, 3. So this minus 1 will reach to 1 and 1 will reach to 3. So this is right shifted. If you right shift by 2, right shifted, that means negative sign. So C of minus n, C of n minus 2 is equal to dn. Are you able to understand this point? From here, if I see the graph, what I can see is that dn is equal to C of n minus 2. There you go. If I am doing the right shift, what I am doing? I am doing the right shift by 2. Are you able to understand this point? And here what I could have written? This is my xt. What is my yt? My yt is e to the power j n. E to the power j n. Here what is the value of omega naught? Here what is the value of omega naught? Omega naught is 2. So it is e to the power j n omega naught t dot xt. So whatever the n you see, that is the important part. I will not call it L, I will not call it N, I will call it M. Okay. So whatever this M you see, that is the important part. So what kind of conclusion we can make? Xt is having Fourier series coefficient of Cn, which is having a fundamental frequency of omega naught. So if I am multiplying e to the power j m omega naught t, then what will happen? My graph will shift right by m. Fundamental frequency will remain the same. And if I am multiplying with minus m, then what will happen? It will shift left by m. There you go. Are you able to understand the point? What I mean to say is that, let's just say this is your xt having Fourier series coefficient of Cn and fundamental frequency is 3 radian per second. Okay. Now what we are multiplying? E to the power minus j 9 t. Okay, xt. So what do you see here? E to the power minus j m omega naught. What is the value of omega naught? That is 3. So m omega naught t dot xt. So here what is the value of m? The value of m here is minus 3. Value of m is minus 3. Minus 3 means it will left shift, and it is, if it is being left shifted, what does that mean? I will put here C of n plus 3 and fundamental frequency will not change. Here you can directly see fundamental frequency will never change. The fundamental frequency will be 2 only. Previously also it was 2 only. What do you think why it is happening? What you are doing? E to the power j m omega naught t multiply with xt. Now xt is having a fundamental frequency of omega naught and this is having a fundamental frequency of m omega naught. When you take the HCF, 100% it has to be omega naught only. Although there is no concept of taking the HCF because they are in multiplication, they are not in addition. So here I cannot take HCF. Are you able to understand the point what I am saying? If someone asks you what is the fundamental frequency of this particular signal and he is saying that xt is having a fundamental frequency of omega naught, then will you say that sir I will take HCF of omega naught and m omega naught? No, you will never say that. Why is that so? Because they are in multiplication. If they were in addition, then I could have said that. But here what will happen, xt will be already represented. What I mean to say is that xt is periodic, right? So what I am doing, I am multiplying e to the power j m omega naught t with xt. xt is periodic, that means xt is c1 e to the power j omega naught t plus c naught plus c of minus 1 e to the power j omega naught t plus c of minus 2 e to the power j2 omega naught t plus c of minus 1 e to the power or whatever it is, c of plus 2 e to the power j2 omega naught t. Here minus sign would be there, here also minus sign would be there. So basically all will be, frequency component will be omega naught, 2 omega naught, 3 omega naught in that manner, right? And that will be multiplied with m omega naught. So what will happen, e to the power j m omega naught t multiply with this one, e to the power j m omega naught t multiply with c naught, e to the power j m omega naught t multiply with this one, e to the power j m omega naught t multiply with this one. Then you will see that always your fundamental frequency will be omega naught only. Are you able to understand this point? Okay, why is that so? Because what this will become, if you multiply both of them, so then what you will get, c1 e to the power j m plus 1 omega naught t. Then if you multiply these two, what you will get, c naught e to the power j m omega naught t. If you multiply these two, what you are getting, c1, only c1, because e to the power minus j omega naught t, yeah, you are getting c1 e to the power j m minus 1 omega naught t. Then in that manner you will keep on getting. If you take the HCF of m plus 1 omega naught t, m plus 1 omega, m plus 1 omega naught, m omega naught, m minus 1 omega naught, then m plus 2 omega naught, m minus 2 omega naught, in that manner whatever it is going. If you take the HCF of all these values, what will become HCF? Omega naught only. So basically if you are multiplying e to the power j m omega naught t, then the fundamental frequency will not change, fundamental frequency will remain the same. And this is 100% certain, always fundamental frequency will be same. I hope you have understood the derivation. Basically I have put this as it is and then I have opened the xt, c1 e to the power j omega naught t, c naught, c of minus 1 e to the power minus j omega naught t, c of minus 2, c2, in that manner, and then I will multiply this function inside. Basically they are in multiplication, so I multiply them. Then what will be the frequency content? I will be getting m plus 1, then directly m, then m minus 1, m minus 2, m plus 2, in that manner all these frequency content I will be getting, right? And then what I need to do, I just need to take the HCF, and what will be the HCF of all these? Omega naught common you can see, so HCF will be omega naught only. Are you able to understand this point? So always the fundamental frequency will never change. Fundamental frequency will be the same, right? So what we need to do here, what I was saying, yeah, what I was saying. So here also fundamental frequency did not get changed. So here I need to see that what is the value of omega naught. Omega naught value is 2. So here 2 is extra multiplied. If 2 is extra multiplied, that means it will be shifted right by 2. Shifted right by 2. Okay. And if we take the right shift, that means we add the negative sign. And here e to the power minus sign is there. That means it is shifted left by 3. Here you can directly see that m value is 3. So it will be shifted left by 3, and whenever we shift left, what does that mean? We take the positive sign. So here just what you need to remember, if negative sign is there, here positive would come, and here if positive sign is there, here negative would come. So this is also an important property only. So here I am writing down the conclusion. What is the conclusion? That e to the power j m omega naught t xt will have Fourier series coefficient of c of n minus m with the fundamental frequency of omega naught only. So another conclusion we have made. E to the power j m omega naught t. So here if m is negative, then it will be plus. If m is positive, then it would be negative only. Basically, if m is positive, then it will be shifted. If m is positive, then it will be shifted right. If m is negative, then it will be shifted left. Okay, so just opposite sign would come here. So did you get this conclusion as well? So another conclusion we have made. So till this point in this slide, whatever the property you see, those are important. Okay, and if a question is coming from Fourier series coefficient, then it will be asked from these property only. What I mean, what I said, if a question is coming from Fourier series coefficient, then it will be asked from these properties only. But now we have to study 3 more properties, and when we study these three more properties, you will realize that why the question will not come from there. Okay, so now we need to study those properties, and once we study it, you will be able to understand why the question will not be coming from these particular properties. Okay, so we will build the property just the way we have always built. In this manner we will build the property, and then you will understand why I am saying that they are not important. Look, such kind of question can come, but this question can be solved using the property as well. But in the examination hall, you will never ever apply the property. You will go by the basic concept. So let's solve the question. You need to find C of n. So can you find Cn? Yes. What is the value of C1? C1 is 1 by 2j. And what is the value of C of minus 1? That is minus 1 by 2j. This you already know, right? Then you need to find D1. What is the value? 1 by 2. What is the value of D of minus 1? That is also 1 by 2. Right? Now Zt is defined as 3 sin t minus 4 cos t. Yeah, so now it can be written as e to the power jt minus e to the power minus jt divided by 2j then minus 4 e to the power jt plus e to the power minus jt divided by 2, right? So what you are getting, 3 by 2j minus 2 e to the power jt, then here minus 3 by 2j minus 2. This will be minus 2, so here I need to write down plus 2. Are you getting this point? Basically here what will be the coefficient of e to the power minus jt? Coefficient of e to the power minus jt will be minus 2 and minus 3 by 2j. Minus 2 and minus 3 by 2j. So this minus sign I am taking outward, so it would be minus 3 by 2j plus 2, right? So this is the Zt we are getting, right? Zt we are getting. So from here what you can see, my g of 1 is 3 by 2j minus 2, and what is my g of minus 1? That is minus 3 by 2j minus 2. So from here what you are getting, 3 into 1 by 2j, can I write it down in this manner? Minus 4 into 1 by 2. Why I am doing so, you will realize. Okay, and here 3 into minus 1 by 2j minus 4 into 1 by 2, right? So 3. What was the value of C of 1? This is C of 1, right? 3 C of 1 minus 4 D of 1. And here this is 3. This value is C of minus 1. And this is D of minus 1. So 3 C of minus 1 minus 4 D of minus 1. Are you able to understand the point? From here can I write it down that my Gn is equals to 3 Cn minus 4 Dn. Basically, what was your Zt? Your Zt was 3 sin t minus 4 cos t. So Fourier series coefficient of Gn is equals to 3 into Fourier series coefficient of sin t, that is Cn, minus 4 into Fourier series coefficient of cos t, that is Dn. Okay, but all these are applicable when fundamental frequency of xt and yt are same. Fundamental frequency of xt is omega naught 1. Fundamental frequency of yt is omega naught 2. That is also 1. That means both are same. So what will be the fundamental frequency of 3xt minus 4yt? Both are in multiplication. What does that? Sorry, both are in addition. What does that mean? I need to take the HCF. So HCF of omega naught and omega naught, what that would be? Omega naught only. So if xt and yt are having the same fundamental frequency, then zt, which is equals to alpha xt plus beta yt, will also have the same fundamental frequency, and then you can apply this particular property. What does that mean? That xt is having Fourier series coefficient of Cn having fundamental frequency of omega naught, yt is having Fourier series coefficient of Dn having fundamental frequency of omega naught. So alpha xt plus beta yt will have the Fourier series coefficient of alpha Cn plus beta Dn. Alpha Cn plus beta Dn, and the fundamental frequency will be omega naught only. So this is the property you can apply only when your fundamental frequencies are same. These two should be same. But what if the fundamental frequencies are different? So let's just say this question is coming in the examination hall. You need to find out the non-zero Fourier series coefficient of GT. This question is coming. You need to solve this question in the examination hall. How will you solve it? What you will do? Sir, first I will find out GT. Always in any question, I am telling this about any question. Always start your answer from wherever it is asked. Basically, they are asking about GT. So my matter of concern will be GT. I will only deal GT now. Now in GT, what do I require? XT and YT. Then I will look at XT and YT. Are you able to understand this point? If they are asking the value of X, then X will be my matter of concern. Now to find out X, what all things are required, then those things will become matter of concern. So this is how you proceed in any question, whether it is from signal system or from any other subject. Are you able to understand this point? So GT is equals to 2. What is XT? Now this is my XT. Here n is going from -1 to 1. It is having Fourier series coefficient of Cn, that I don't care. So can I write down my xt? Yes. So my xt is, here you put -1, so it will become 2 e to the power j minus pi by 2t. Then n equals to 0 you put here, plus 1. Then n equals to 1 you put here, 1 by 2 e to the power j pi by 2t, plus, then you put n equals to -1 here. What we are doing, really sorry, this is xt is completed, plus 3. What about yt? What about yt? So you put n equals to -1 here. What you are getting? 1 by 2 e to the power j minus pi t. Then you put n equals to 0 here. What you are getting? Plus 1. Then you put n equals to 1 here. What you are getting? 2 e to the power j pi t. Are you able to understand this point? Now what is the fundamental frequency of this particular expression? Pi by 2t you can see, pi by 2t you can see, pi you can see, and pi you can see. So pi by 2, pi by 2, pi, pi. DC value will not affect in DC value will not affect in your fundamental frequency. So what will be the fundamental frequency? That will be the HCF of pi by 2 and pi. That would be pi by 2. So this is the fundamental frequency. So this value I am taking as omega naught. So what I can write down? 4 e to the power minus j omega naught t plus 1 plus 2 into 1 by 2 will be 1 only, e to the power j omega naught t, plus 3 into 1 by 2 will be 3 by 2 e to the power minus j 2 omega naught t, plus 3 plus 6 e to the power j 2 omega naught t. Say yes or no? Pi by 2 is replaced with omega naught. So 4 e to the power minus j omega naught t plus, why I am writing 1 here? This is 2. So 2 into 1 will be 2. 2 into 1 by 2 will be 2 into 1 by 2 will be 1 only, e to the power j omega naught t. Then 3 by 2 plus 3 plus 6. Is that clear to you? All good? So what is the value of c of minus 2? C of minus 2 is 3 by 2. Not c of minus 2, really sorry. This is having a Fourier series coefficient of gn. So I am writing g of minus 2. G of minus 2 is 3 by 2. What is g of minus 1? G of minus 1 is 4. What is g of 0? That is 2 plus 3, 5. 2 plus 3, 5. G of 1. G of 1 is 1 and G of 2 is 6. G of 1 is 1 and G of 2 is 6. So this is how I would have solved in the examination hall. That's these are my non-zero Fourier series coefficient, and this is my answer. But let's try making some conclusion from here, because I can see that there is something called linearity, but both are having different fundamental frequencies. This is saying that here fundamental frequency is pi by 2, and this is saying that here fundamental frequency is pi. So we know that we cannot apply linearity property, but smartly we can apply the linearity property here. Let's see how we can apply. So can you find out the value of C1? C1 was 1 by 2. 1 by 2, right? But let's start from C of minus 1. So C of minus 1 was 2, C of 0 was 1, and C of 1 was 1 by 2, right? Is that clear to you? 2, 1 and 1 by 2. If I go here, 1 by 2, 0 and 2. D of minus 1 was 1 by 2, D of 0 was 1, and D of 1 was 2. What we are doing? 2xt plus 3yt. 2xt plus 3yt. Look, if I had directly applied the linearity property, then my g of n would have been directly, blindly if I do, 2c of n plus 3d of n. But this is not the answer, because as per this, what I will be getting? 2g of c1 plus 3d of 1, right? 2c1 plus 3d1, that would be the value of g1. So what is the value of c1? c1 is 1 by 2. So 2 into 1 by 2 will be 1 plus 3 d1. What is the value of d1? d1 is 2. So I would have been getting the value 7. So which is wrong. So this we are getting, that is wrong. But how I could have got it correct? Look, this is having a fundamental frequency of omega naught. If I say this is omega naught, then what will be the fundamental frequency of this one? 2 omega naught. This is having a fundamental frequency of omega naught, and this is having a fundamental frequency of 2 omega naught. So with respect to omega naught, they are the first harmonic, right? They are the first harmonic, and this is 0th harmonic, or I can say this is DC. With respect to 2 omega naught, this is first harmonic. What I am saying again, listen to me very carefully. With respect to 2 omega naught, this is first harmonic. With respect to omega naught, it is second harmonic. With respect to omega naught, it is second harmonic. Say yes or no. And this is DC only. What I see, this is having omega naught, this is having 2 omega naught. That means HCF of omega naught and 2 omega naught will be omega naught. So with respect to omega naught, this is first harmonic, this is DC, and this is first harmonic. And with respect to 2 omega naught, this is first harmonic. Basically, this shows that this is having a frequency component of 2 omega naught. This is also having a frequency component of 2 omega naught, because what I would have written, d1 e to the power j 2 omega naught t. Whatever the value of omega naught was there, that I don't care. But from here I get to know that this I would have written e to the power j pi t, and pi t can be written as e to the power j pi by 2t, and pi by 2t I am calling as omega naught. So if I look both of them together, then this becomes my first harmonic, DC first harmonic. This becomes my second harmonic with respect to omega naught. Second harmonic with respect to omega naught. Are you able to understand this point? So effectively I will call this as d of minus 2. Effectively I will call this as d naught only, and effectively I will call this as d of 2. Now if I apply this property, that what will be the value of g of 2? So you see I will be able to get it. 2c2 plus, or here I had done g1. So what I will do? 2c1 plus 3d1. What is the value of c1? That is 1 by 2 plus 3d1. d1 is there? No. d1 is 0, because this has become the second harmonic. So d1 is not even there. So what is the answer I am getting? g1. So g1 is equals to 1. Yes, this is true. Let's check at g of minus 2. G of minus 2. What will be g of minus 2? 2c of minus 2. 3d of minus 2. 2c of minus 2. What is the value of c of minus 2? Not even there. Plus 3. D of minus 2. Although this is d of minus 1, but this has become second harmonic. So this will be 1 by 2. So what is the answer I am getting? 3 by 2 is equals to g of minus 2. Is that correct? Yes, this is also correct. Let's see for the DC as well. DC will be all correct. Why is that so? Because what will be my G naught? G naught will be 2C naught plus 3D naught. So that did not change. So 2 plus 3. So 2 into 1 plus 3 into 1. So G naught is 5. So are you able to understand the point? Why did I say that these properties are good for nothing? Because this will work directly, it will work only when the fundamental frequency is same. If fundamental frequency is different, then you need to use your brain like this. But do you really think that in the examination hall you will be able to use the brain like this? No. In the examination hall, if I see this kind of question, blindly I will go like this. Blindly, closing the eyes. But one thing, if I am smart enough, I would say, okay, these are the, like if this is omega naught, this is 2 omega naught. So if I am smart enough, I would see, okay, HCF will become omega naught. That means this will have the omega naught fundamental frequency. So with respect to this omega naught, with respect to this particular omega naught, this will become the fundamental frequency and this will become the second harmonic. Basically here it will be omega naught and this will be 2 omega naught. So here GT will have my fundamental frequency equals to 2 omega naught. With respect to this, this is my Jn omega naught and this is my Jn2 omega naught. So here I will get to know that my D2, D of minus 2 and D0 I can get from here. C1, C of minus 1 and C0 I will get from here. And then I can apply the linearity property. So if you are able to think this much in the examination hall, then you might be able to save 1 minute or 1.5 minutes. But gate examination is not the examination of speed, it is the examination of accuracy. So better be on the safer side, go like this. Now who knows, by some means they can ask you these kind of concept as well. That's why I am teaching it here. Otherwise directly I should have taught till this point only that if both are having same fundamental frequency, then job is done, alpha Cn plus beta Dn. But this will work for only same fundamental frequency. But if the fundamental frequencies are different, then we can also use our brain. So that's why I said these properties are good for nothing. There is very rare chance that you will be using these properties anywhere in the examination hall. Okay. Till this point, these properties are never used in the examination hall. Till this point, in any examination, either in ESE, I'm not sure about ESE, but in gate examination, never ever these properties have been used. Okay. Let's go to the next property now, which is multiplication in time domain. So basically xt and yt is being multiplied. So what will happen to your gn? Basically here if it is gt, then what will be your Fourier series coefficient of the multiplication? So here what is the fundamental frequency? Again you can see something. Fundamental frequency is same. Omega naught 2 is also 1. That also I can call as omega naught. GT, xt into yt. So can you say that HCF of omega naught and omega naught, that will be the fundamental frequency? Absolutely not. That HCF thing works only when there is addition or subtraction, right? So here I have to calculate sin t dot cos t. Can I write it down this as 1 by 2 into 2 sin t dot cos t? That would be 1 by 2 sin 2t. 1 by 2. So here what do you see? What is the fundamental frequency here? What is that? I am calling fundamental frequency as omega p. So fundamental frequency is 2. What is this? This is fundamental frequency. Right. So this is your 1 by 2 e to the power j omega pt minus e to the power minus j omega pt divided by 2j. So from here what do I see? My g of 1 is 1 by 4j and g of minus 1 is minus 1 by 4j, right? Along with that I could have written my C1, Cn and Dn as well. So what will be the value of your C1? Or first write down C of minus 1. So this is sinusoid, right? So that would be minus 1 by 2j. What was your C of 0? That was 0 only. And what was your C of 1? That was 1 by 2j. What about your D of minus 1? That was 1 by 2. What was your D of 0? That was 0. What was your D of 1? That was 1 by 2. So what is your Cn? Your Cn is minus 1 by 2j, 0 and 1 by 2j. Can I write it down in this manner? Yes, I just made it a sequence because I told you Cn is nothing but a sequence only. Sequence of discrete frequencies, that means omega naught, 2 omega naught in that manner, right? And but here we write down 1 and 2, 1, 2. What does 2 shows? That means it is second harmonic. 3 shows it is third harmonic, right? So this is your C of n, and can I write down D of n? 1 by 2, 0 and 1 by 2. Now what I am doing is that I am taking the convolution of a Cn convolution Dn. This is what I am doing. Okay. So can I calculate the convolution? Yes. This is your finite duration sequence. For finite duration sequence, what kind of method I can use? This is a easier method. So here what I can do? Tabular method I can use. Minus 1 by 2j, 0, 1 by 2j. This is your n equals to minus 1. This is your n equals to 1. This is your n equals to minus 1. This is your n equals to 1. So this convolution I am doing. Let's see whatever the result I get. 1 by 2, 0 and 1 by 2. So this will become 1 by 2 will be multiplied with all these. So minus 1 by 4j, 0 and 1 by 4j. Then 0, 0 and 0. Then minus 1 by 4j, 0 and 1 by 4j. 1 element, 2 element, 3 element. I cannot take 4, so I will come back to 2 element and then 1 element. Okay. So I am calling this as alpha n. Okay, alpha n I am calling. So what is the value of alpha n I am getting? Minus 1 by 4j, 0, 0, sorry 0 and then minus 1 by 4j plus 1 by 4j, that will also be 0. Here minus 1 by 4j, then 0 plus 0 will be 0. Minus 1 by 4j plus 0 plus 1 by 4j, that will also be 0. Next 0 plus 0 will be 0 and then 1 by 4j. According to this will be n equals to minus 2 because minus 1 minus 1. So it will start from n equals to minus 2 and here plus 1 plus 1, it will go to n equals to 2 and this should have been n equals to 0 then, right? So what you will say that sir, according to me alpha of minus 2 is minus 1 by 4j and according to me that sir, alpha of 2 is 1 by 4j. You are not wrong in saying so, but here what did you get? G of 1 is 1 by 4j, G of minus 1 is minus 1 by 4j. Although the values are same, alpha of minus 2 minus 1 by 4j, G of minus 1 minus 1 by 4j, alpha of 2 1 by 4j, G of 1 1 by 4j. But the problem is with harmonics. G of 1, G of minus 1, first harmonic, and this is saying it is second harmonic. But if you look closely, this is first harmonic only. Why is that so? Because what was the fundamental frequency? Omega naught. What was the fundamental frequency? Omega naught. What was the fundamental frequency here? 2 omega naught. So if I say G of 1, what does that mean? That means this is the first harmonic with respect to 2 omega naught. This I can write down as 2 omega naught, right? So this is the first harmonic with respect to 2 omega naught. This is also first harmonic with respect to 2 omega naught. But with respect to omega naught, what this will become? Second harmonic. And with respect to omega naught, what this will become? Second harmonic. Are you able to understand this point? Say yes or no. I hope you are able to understand this particular point. Okay. What I mean to say is that what I did, I applied the multiplication property. In multiplication property, I got to know that my G of n is having a fundamental frequency of 2 omega naught. Then what property I know? Property that I know that if I am multiplying two signal, if I am doing the multiplication in time domain, then convolution can be done with respect to the Fourier series coefficient. So exponential Fourier series coefficients can be convolved. So I said that my G of n is equals to Cn convolution with dn. What I said that my G of n is equals to Cn convolution with dn. But there is a catch here. When you find out the values, you get to know that this is coming out to be the second harmonic and this is coming out to be, all these are coming out to be second harmonic and this is zeroth harmonic only. So no need to worry about zeroth harmonic, but you need to worry about second harmonic. So will it be actually second harmonic? it will be second harmonic. It is second harmonic with respect to the frequency omega naught, and this is also second harmonic with respect to the frequency omega naught. But what is the actual fundamental frequency? Actual fundamental frequency is 2 omega naught. So actually this becomes first harmonic. Actually this becomes first harmonic. Are you able to understand this point or not? Again, I am saying these properties are good for nothing, right? How they are good for anything, right? In the examination, if this question is coming, like, will you be able to think, okay, omega naught, then my fundamental frequency is omega naught, but when I multiply, my fundamental frequency becomes 2 omega naught. If I do the convolution, I am getting the answer. But here, what do I see? I considered this particular sequence was having a fundamental frequency of omega naught, and this particular sequence was also having a fundamental frequency of omega naught. So the final answer would be coming considering the fundamental frequency as omega naught. So if my fundamental frequency was omega naught, then this would be the second harmonic. If my fundamental frequency was omega naught, then this would be the second harmonic. But what is my fundamental frequency? Actually, this is having a fundamental frequency of 2 omega naught. This is having a fundamental frequency of omega naught. This is having the fundamental frequency of omega naught. So when you convolve both of them, the answer would come with respect to the omega naught fundamental frequency. But actually g of n will have 2 omega naught fundamental frequency. So if you are getting the second harmonic, that means that second harmonic is actually first harmonic for g of n. So this is the actual way of property. How it is taught? Usually it is written down in this manner. Just one second. Usually how it will be written down, that xt is having Fourier series coefficient of Cn, yt is having Fourier series coefficient of Dn, then xt dot yt will have Fourier series coefficient of Cn convolution Dn, which I don't think is correct. This is not completely correct. In the textbook as well, it will be written like this only, but it is not completely correct. Xt is having fundamental frequency of omega naught, this omega naught, so this will have fundamental frequency of 2 omega naught. So you need to think in the examination hall that whatever the convolution will give, this will give answer as per omega naught fundamental frequency. You will get the answer according to omega naught as fundamental frequency, but your actual fundamental frequency is 2 omega naught. Then here, if you are getting the second harmonic, that will become first harmonic. If you are getting fourth harmonic here, that will become the second harmonic. Are you able to understand this point? If I am getting fourth harmonic here, if I do this process and I get the value as alpha 4, I am saying that the answer would be alpha n. If I get the value of alpha 4, let's just say alpha 4 is 1 by 5. Alpha 4 is 1 by 5. What does that mean? That this is the frequency component with respect to 4 omega naught. If I am getting alpha 4, that means this result will be with respect to omega naught. That means this is 4 omega naught, and 4 omega naught will become 2 into 2 omega naught. That means for this particular thing, xt dot yt, if I call this as gt, so for gt 2 omega naught is the fundamental frequency. So this will become the second harmonic for gt. This will become second harmonic for gt, second harmonic. So will you be able to think in the examination or in this manner? Okay, anyway you need to think if you are applying the property, but there is very rare chance that I will be applying the property in the examination. Are you able to understand this point? I will not apply the property in the examination, right? Where this property can be useful? Do you remember the area property? GT convolution with HT would be equals to area of GT into area of HT, right? Similarly, here if I do Cn convolution Dn will be equals to summation n goes from minus infinity to infinity Cn dot summation n goes from minus infinity to infinity Dn, right? So if they frame a question like this and then they ask you, sorry, here what I need to write, what I am doing here, yeah, area of, sorry, here I should write area of GT convolution HT, area or I can say summation n goes from minus infinity to infinity, right? Cn convolution Dn would be equals to this. So basically they can give the Fourier series coefficient of xt, then they can give the Fourier series coefficient of yt as well, and then they will ask you, if I multiply both of them, then I get gt, and that gt is having a Fourier series coefficient of gn. What will be the value of n minus infinity to infinity g of n? This question they can ask. Are you able to understand the point? What I am saying? What they will say, xt is having a Fourier series coefficient of cn. Xt is having a Fourier series coefficient of cn, and yt is having a Fourier series coefficient of dn. I multiply both of that. They will give the value of cn. They will give the value of dn as well. I multiply both of the signal, xt dot yt I do, and I get a new signal that is gt, and gt is having a Fourier series coefficient of gn. What is the value of this particular thing? Then you would know that gn is equals to cn convolution dn. Gn is equals to cn convolution dn, and here you can apply the area property that this goes and this goes separate, right? Area property you have already seen. If I convolve two signal and then I get another signal, right? So area of that another signal will be equal to the area of previous two signal multiplication, right? So this property we have already seen. Here it was as summation, right? So this is what you can do in the examination. All these kind of questions are asked. They will mention cn, they will mention dn. So what you need to do, you just need to do the summation of cn, then you need to do the summation of dn, then this will be the answer. Okay, so let me frame a question here. Okay, actually this will make a very good question. So I will frame a question here and then we will see the answer. Yeah, so this is the question. We need to xt is having a fundamental frequency of omega naught. All these Fourier series coefficient are there. Then gt is 2x square t having Fourier series coefficient of gn. Forget about the fundamental frequency. This is just of no matter of concern. And then you need to find out the value summation n goes from minus infinity to infinity g of n. This is what you need to find out. Okay. So what I can see here, gt is 2 into xt dot xt, right? 2 into xt dot xt. So what will be your gn? 2 cn convolution cn. Now do you need to think about fundamental frequency here? That sir, xt is having a fundamental frequency of omega naught, then sir what will be the fundamental frequency of gt, then with respect to that sir I will find out g1 g of minus 2. Nothing you need to think about it. Why is that so? You don't need to think about all these things. Why is that so? Because you need to calculate the summation. No, what if I calculated this particular thing and then I calculate the summation? What is the answer? Minus 1 by 4j plus 1 by 4j, 0. Or directly from here as well, the answer is 0. Whether it is g1, g of 2, g of 3, g of 4, g of 10, g of 500, does that matter? Because I am doing the summation from minus infinity to infinity, no? So how does that matter? That it is first harmonic or second harmonic? You are just adding up all the harmonics. If I do this particular thing, that means addition of all the harmonics. 0th harmonic, first harmonic, second harmonic. So how does that matter that sir, what will be the first harmonic, what will be the second harmonic? So if they are asking the question on this property, then certainly they will ask this question. That's my sure guarantee. Okay, if they are asking the question on property, then this question will be asked. That 100% I am sure. Because you know that this property is failing. This property is not that straightforward. That cn convolution with dn is equal to gn. That is wrong. Why is that so? Because of the fundamental frequency. First one is having omega naught, second one is having omega naught. Now I am not sure what will be the fundamental frequency of gt. How I am writing 2 omega naught here. I am not sure what will be the fundamental frequency of gt. But this convolution will give the result with respect to fundamental frequency of omega naught. And with respect to fundamental frequency of omega naught, whatever the value of alpha n I am getting, that harmonics will be with respect to omega naught. I am not sure what will be the fundamental frequency of gt. So here the problem will be with the harmonics. This will say that this is second harmonic, but for gt this was actually first harmonic. But actually it is giving the, at least it is giving you the value, right? Minus 1 by 4j plus 1 by 4j. So minus 1 by 4j plus 1 by 4j. So at least it is giving you the value. And that is what matters here. If I do summation n goes from minus infinity to infinity, g of n, that would be equals to 2 you take common, n goes from minus infinity to infinity, c of n dot n goes from minus infinity to infinity, c of n, 2 into, what is the value of summation n goes from minus infinity to infinity c of n? Plus 1 by 2j minus 1 by 2j will be 0, 1 by 2 and 3, that would be 4, and this will also be 4. 1 by 2, 1 by 2, 1, 1 plus 3, 4. So what you are getting? 32. This is the answer. So this is how I will be solving in the examination. Are you able to understand the point? Here some people will be finding x of t, because I have framed the values in this manner that you can find out x of t. Then you will do the double, and then you will do the square, and then you will find the Fourier series coefficient, and then you will be adding them up, which is not a wise option, right? And here what people would have thought, some people would have gone by the concept of power as well, right? Some people can go with the concept of power as well, but that will also not be a wise idea. So this is the good possible approach. In the examination, you need to think that xt is being multiplied with xt. Okay, so 32 will be the answer. Again, the catch here was I took the same fundamental frequency, omega naught and omega naught. What if the fundamental frequencies are different? What if the question is like this? Sin 2t, yt is having cos t. You need to find the gn value. You need to find the Fourier series coefficient of xt dot yt. So what is your gt? gt is sin 2t into cos t. That would be 1 by 2 into 2 sin 2t cos t. So 2 sin a cos b. What that would be? Sin a plus b plus sin a minus b. Sin a plus b plus sin a minus b. What do you see from here? What is the fundamental frequency here? Here the fundamental frequency becomes 1. Why is that so? Because you take the HCF of 3 and 1. So that would be 1 only. So it would be 1 by 2 sin 3 omega naught t plus sin omega naught t, right? So that would be 1 by 2 e to the power j 3 omega naught t minus e to the power minus j 3 omega naught t divided by 2j plus 1 by 2 e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j. It is having a fundamental frequency of gn. Then what is the answer? G of 3 is 1 by 4j. G of minus 3 is minus 1 by 2j. G of 3 is 1 by 4j. G of minus 3 is minus 1 by 4j, sorry. Minus 1 by 4j. G of 1 is 1 by 4j again, and G of minus 1 is minus 1 by 4j. So these are the answers. These are the actual answer, right? These are the actual answer. But if I do the convolution, where will I go wrong? So can I find C1 from here? Basically, if this particular thing is given, I am just copying this particular thing. So what will be the value of C1? This will treat, what is the fundamental frequency here? Fundamental frequency is 2. And what is the fundamental frequency here? That is 1. So this will treat omega, this will treat 2 as fundamental frequency. So here the value of C1 will be 1 by 2j. Is that clear to you? And value of C of minus 1 will be minus 1 by 2j. Is that clear to you or not? Are you able to understand this point? If I ask you what is the value of C1 and what is the Fourier series coefficient of this particular signal, then you will say that, sir, first harmonic is 1 by 2j and the first harmonic is minus 1 by 2j as well. This is what you will say, right? Do you agree to this point, right? And what is your D1? That is 1 by 2, and D of minus 1, that is 1 by 2. So from here, what is C of n? That is minus 1 by 2j, 0 and 1 by 2j. And what is D of n? That is 1 by 2, 0 and 1 by 2. If you convolve both of them, what will be the result you will be getting? Have we done the convolution? Yes, the same thing. Cn minus 1 by 2j, 0, 1 by 2j. minus 1 by 2j, 0, 1 by 2j, and here 1 by 2, 0, 1 by 2, 1 by 2, 0, 1 by 2. So if I convolve both of them, if I do the convolution of Cn, convolution Dn, which I have already done, so what I will be getting? Minus 1 by 4j, 0, 0, 0, 1 by 4j, which is absolutely wrong, because here you can see that 1 by 4j minus 1 by 4j, 1 by 4j minus 1 by 4j. There are two non-zero harmonics, but here only one non-zero harmonic you are getting. Doesn't make any sense. Basically, whatever the convolution result that you have wrote down here, that doesn't make any sense. Everything is wrong about this, because here at least 4 non-zero terms should be there, no? 1, 2, 3, 4. 4 non-zero terms should be there, but here 2 non-zero terms are coming. How I can make it correct? What do you think? If this is omega naught, this is 2 omega naught, what do? I take the HCF of omega naught and 2 omega naught. What that would be? Omega naught. So with respect to omega naught, this will throw first harmonic. With respect to omega naught, this will throw first harmonic, and with respect to omega naught, this will throw second harmonics. Are you able to understand this point? How would I make the correction? That means my Dn remains as it is. Because what did I do? I took HCF. Out of nowhere, blindly I took the HCF. HCF was omega naught. So with respect to omega naught, this will be same as it is. This will throw first harmonic only. But here the frequency content is 2 omega naught. Frequency content is 2 omega naught. That means all these becomes the second harmonic. Are you able to understand the point? That's why I say that these properties are good for nothing. Whenever you study these properties, those who have already studied it, they will see that in their notes only this much is written. That's it. In their notes only this much is written. But actually the properties are very deep. They are good for nothing. You cannot apply these properties everywhere. This is the only conclusion of this lecture, that you cannot apply these properties everywhere. This is the only conclusion, and that's why in the examination never ever these properties have been asked. So you don't need to think too much that, sir, how I will be able to remember all these things in the examination hall. These questions will not even come. And if such kind of questions is coming, if such kind of questions are coming that two signal are given and then you need to find out the Fourier series coefficient, then you go by the conventional approach. You don't apply the property there, because property will fail. Are you able to understand this point? Are you able to appreciate this point, that property will fail? That's it. So this thing, like you will not have to think all these things in the examination hall, that, sir, how omega naught, true omega naught, then, sir, how I will take the HCF, then, sir, how I will treat this as first harmonic, and then with respect to omega naught, they will become the second harmonic. So how will I think that much? You don't need to think that much. In the examination hall, you will be solving the problem like this. That's it. In this manner, you will be solving the problem in the examination hall. I am just telling you here that I would have applied the property. If an interviewer is telling me that you apply the property, how will I apply that? So I would say that my D of n remains as it is. 1 by 2, 0, 1 by 2. You are studying this course comprehensively. That's why all these things are there. If I am teaching it in RIB or crash courses, then all these things will not be there, right? And what will be your C of n? Your C of n. Now this will become second harmonic. This will also become second harmonic. So this will be C of minus 2. Then first harmonic is 0. 0th harmonic is already 0. Then first harmonic again 0, and this will become the second harmonic. Now you do the convolution of both of them. What I actually did is that I made the fundamental frequency of this one also as omega naught. If this was the fundamental frequency omega naught, here also I made the fundamental frequency as omega naught only. If for this particular question, if my fundamental frequency was omega naught, then these values I will be getting for this particular question. What I am saying, for this particular question, if my fundamental frequency was omega naught, then these will be the harmonics I will be getting. This would become my second harmonic. So this is what I did. I saw that my fundamental frequency is omega naught here. This fundamental frequency I also made omega naught. So these become my second harmonic. Now I will do the convolution. That would be 1 by 2j, sorry, minus 1 by 2j, 0, 0, 0 and 1 by 2j. 1 by 2, 0 and 1 by 2. Minus 1 by 4j, 0, 0, 0, 1 by 4j. Then 0, 0, 0, 0, 0. Minus 1 by 4j, 0, 0, 0, 1 by 4j. First, second, third, here also 3 element, then also 3 element, then 2 element, and then 1 element. So what I am getting? Minus 1 by 4j, 0, minus 1 by 4j, then again 0, then plus 1 by 4j, then again 0, and then plus 1 by 4j. So here what I was getting? Minus 1 by 4j, minus 1 by 4j, minus 1 by 4j, minus 1 by 4j, plus 1 by 4j, 1 by 4j. Are we getting the same thing? Minus 1 by 4j, minus 1 by 4j, 1 by 4j, 1 by 4j. According to this was n equals to minus 2. This was n equals to minus 1. So minus 2 minus 1, this would have been n equals to minus 3. So minus 3, minus 2, minus 1, 0, 1 and 3. So is this our g of n? Absolutely. Same g of n I am getting. Here I am calling this as alpha n. Alpha n. What I am doing? Alpha n is equals to Cn convolution with Dn. So is it coming to g equals to g of n only? Yes. Here there was no issue of harmonics. Why is that so? What I am saying, here there is no issue of harmonic. This is third harmonic, this is also third harmonic, third harmonic, third harmonic. Third harmonic, third harmonic, first harmonic, first harmonic, first harmonic, first harmonic. There was no issue of the harmonics. Why is that so? What do you think? Why this happened? Because what did I do? I treated this as fundamental frequency of omega naught. I treated this as fundamental frequency of omega naught. So final answer is coming considering fundamental frequency of omega naught. Right? Here also, in this question as well, the final answer came considering fundamental frequency as omega naught. This final answer came considering fundamental frequency as omega naught. Why is that so? Because our inputs were having the fundamental frequency of omega naught, but actually our GT was having a fundamental frequency of 2 omega naught here. So then I got to know that this was my first harmonic. It is not second harmonic, it is actually first harmonic for g of n. Here what is the scene? Fundamental frequency 2 omega naught, fundamental frequency omega naught, and when I calculated all these things, what is the frequency here? 1. If I call this as omega naught 1, that was 2. Omega naught 2 was 1, and what frequency came here? That was also 1. So if this was omega naught, this was 2 omega naught, then final answer is also having a fundamental frequency of omega naught. So calculation is done with respect to the fundamental frequency of fundamental frequency of omega naught, and final answer g of n is also having the fundamental frequency of omega naught. That's why harmonics are also the same. Is this concept clear to you or not? Crystal clear it should be. This concept should be crystal clear to you, that whenever I am performing these operations, so first thing would be, what it will do is that if I am saying that gt xt dot yt is gn is cn convolution dn, then what it is doing, first it will take the HCF of these two, then it will convert omega naught 1 and omega naught 2 in HCF of these two. Let's just say, what I mean to say is that, let's just say this is having a fundamental frequency of 6 and this is having a fundamental frequency of 8. So what will happen? What is the HCF of 6 and 8? 2, right? HCF of 6 and 8 is 2. So this will become, HCF is 2. So I am saying that omega naught is 2. Omega naught is 2. So this will become 3 omega naught. This will become 4 omega naught. And let's just say here first harmonic was present. First harmonic was present, and here also first harmonic were present. Here also first harmonic were present. But actually these will become third harmonic and third harmonic. Why is that so? Because you will be performing the operation with respect to omega naught. So 6 is actually the third harmonic for fundamental frequency of 2. So this will become third harmonic, they will become third harmonic, and they will become fourth harmonic. They will become fourth harmonics. and then you will write down your Cn, then you will write down your Dn, and you will perform the calculation. Whatever the answer that you will be getting, that you will be getting with respect to 2 radian per second. Now what if this is having a fundamental frequency of I don't know what will be the fundamental frequency. Let's just say this is having a fundamental frequency of 6 radian per second. I'm not sure what is the fundamental frequency, or let's say this is having a fundamental frequency of 14 radian per second. This is the fundamental frequency of this one. The answer is coming with respect to 2 radian per second. The answer is coming with respect to 2 radian per second. So here, let's just say I call the answer as alpha n. My alpha 7 value is minus 1 by 2, and my alpha minus 7 is plus 1 by 2. So what do you think? What is the value of g of 1? Alpha 7. What is the meaning of alpha 7? That means it is having a frequency of 14 radian per second. Alpha 7. Alpha 7. What is the meaning of alpha 7? If fundamental is 2, this is the 7th harmonic. That means it is having a frequency of 14 radian per second. And actually, GT is having a fundamental frequency of 14 radian per second. That means this will become the first harmonic. So G1 will be equals to alpha 7. Are you able to understand the point? This is the process that is happening. If you are able to understand it, if you are able to remember it, then you can remember. Otherwise, what is the only conclusion you will remember from all this discussion? The only conclusion you will remember is that xt, yt, if I do the multiplication, then I will do the convolution for the Fourier series coefficient. That's it. This is the conclusion you will remember. But this property is not as simple as it looks like. There are a lot of things involved in that. So as a conclusion, you will remember all these things. Here we studied this particular thing. In the last what we studied, xt was having same thing was there. I am just writing new zt was alpha xt plus beta yt. So this was also having the Fourier series coefficient of Zn, that would be equals to alpha Cn plus beta Dn. But this property is also not that straightforward. But one thing we are sure that it will have the fundamental frequency of HCF of omega naught 1 and omega naught 2. But this is not the matter of concern here. Only if you only want to remember the property, then these statements you will remember. On crude level, on very surface level, you can remember these statements. But these statements are not that straightforward that it's look like. What it does is that whatever the frequency these guys are having, first it will take the HCF, and whatever the HCF you are getting, that HCF will be treated as fundamental frequency. Now with respect to that fundamental frequency, every calculation will be done, and whatever the answer we are getting, that answer will be there with respect to the HCF fundamental frequency that you have got, and then you need to convert according to the convenience. Is that okay for you or not? So these two properties we have studied, which are actually good for nothing. So no question will be asked, but I wanted to teach you in this much depth that at least you understand why questions are not coming from this particular topic. Okay. Next we need to study a topic that is known as periodic convolution. So convolution we have studied, right? What kind of signals we used to take? E to the power minus ut, convolution with the ut, rt convolution with ut. These kind of signals we used to take. So if you go back to your notes and see, when we studied the convolution, we only took non-periodic signal. All the signals were non-periodic. But what if the signals are periodic? So what will be the convolution formula? So what was the general convolution formula for a periodic signal? That was, you take the integration from minus infinity to infinity, x of tau, h of minus tau plus t d tau, right? So for periodic, what do you do? Everywhere when we have studied periodic signals, what is the changes that we have done? Always the limit we have changed to one time period. That's it. Nothing else you need to do. The limit has changed to one time period, and the same process is there. This function remains as it is, another one is inverted and then shifted. There you go. Just the limit has changed to one time period. Here you are integrating for minus infinity to infinity. Now you will integrate only for one time period. That's it. Nothing else is there. Is that okay for you? Okay. So now we will start doing the calculation. Try doing this calculation on your own. I will take a pause. You do it on your own. You need to find GT, convolution of sin t convolution with cos t. So what you will do? GT will be equals to, yeah, and what will be this T naught? What will be this T naught? T naught will be, this will be periodic. Let's just say this is periodic with T naught 1 and this is periodic with T naught 2. So this T naught will be LCM of T naught 1 and T naught 2. Or if I talk about fundamental frequency, then what will be omega naught? Omega naught will be HCF of omega naught 1 and omega naught 2. So here sin t convolution with cos 2t. So here what is the value of omega naught 1? That is 1. What is the value of omega naught 2? That is also 1. So what will be omega naught? HCF of 1 1. What that would be? That would also be 1. So you need to integrate for one time period I need to take, no? So what will be T naught? 2 pi by omega naught. So you need to integrate for 0 to 2 pi. Time period you need to take. Not here you do not write fundamental frequency. If you are integrating with respect to time window, then you have to write down the limit of time only. So this limit of time I am taking 0 to 2 pi. Sin tau remains as it is. Cos is inverted and then shifted. So what you will do? 2 sin A cos B. So 1 by 2 I divide by 2 and then I will multiply by 2. So 2 sin A cos B. This formula I will apply. So what is the formula of 2 sin A cos B? Sin A plus B, sin A plus B plus sin A minus B, sin A minus B, right? So 1 by 2. This I can break into two integrations, 0 to 2 pi sin t dot dt plus 0 to 2 pi sin 2 tau minus 2 dot d2, right? What I am doing, I am breaking this as a time period of t naught. Basically in one time period, what is the time period of this particular thing? T naught is equals to 2 pi. What is the time period of this particular thing? That is, time period here is 2 pi by omega naught. That 2 pi by omega naught. Omega naught value is 2 here, right? Value of omega naught is 2 here. So what is the time period? Time period is pi. So there is a sinusoid which is shifted. There is a sinusoid which is shifted, having a time period of pi, and you are integrating it for 2 time period. What does that mean? That you are integrating it for 2 cycles. So positive area, negative area, positive area, negative area, all will cancel out and this will be 0 only. Look, one thing you can do is that you can perform this simple integration. 0 to 2 pi, you can perform the integration on your own. 0 to 2 pi, what will be integration of sinusoid? That will be cosinusoid. Divided by 2 it will come, then you put the limit of 0, you will put the limit 2 pi as well. So you put the limit, you will get the answer to be 0 only. Or what you can think, that this is a sinusoid which is shifted. Sinusoid which is shifted by t. What is the time period of this sinusoid? That is pi. And you are integrating for 0 to 2 pi. That means you are integrating for 2 time periods. You are integrating for 2 time periods. And if you are integrating for 2 time periods, that means positive area is equals to negative area, positive area is equals to negative area. That means this total integration will be equals to 0. There you go. So this integration is 0. What will happen to this one? Really sorry. This was d tau, right? You are integrating with respect to tau. You are integrating with respect to tau. So sin t is a constant here. Are you able to understand this point? Sin t will come out. Sin t is a constant. And then you will integrate 0 to 2 pi dot d tau. So what this will become? This will become 2 pi only. So what is the answer we are getting? Pi sin t. This is the answer we are getting. This is our gt. Okay, pi sin t. So answer of first one is sin t convolution with cos t is equals to pi sin t. In the similar manner, we will do all these convolution. Sin t convolution with sin t, cos t convolution with cos t, sin t convolution with cos 2t. Okay, and then you will try to write down these conclusions on your own. Okay, so try doing all these things on your own. I have taught this thing, right? Sin t convolution with sin t you will do, cos t convolution with cos t you will do, sin t convolution with cos 2t you will do, and then you will try to complete this slide. Okay, so I will take a pause, but you try doing it on your own. You can do it. Okay, this is my confidence on you that you can do it. Okay, so try doing it. Okay, so let's start. Convolution of sin t convolution with sin t. So what we will do, gt will be, first what will be the fundamental frequency? That will be 1 only, because you can see that HCF of 1 and 1 will be 1 only, right? So what will be the time period? Time period will be 2 pi. So you are integrating for 2 pi. Sin tau remains as it is, minus tau plus t. Again 2 sin A cos B. Sorry, 2 sin A sin B. 2 sin A sin B. What is the formula of 2 sin A sin B? That is cos A minus B minus cos A plus B, right? Cos A minus B. Cos A minus B. 2 sin A sin B is equals to cos A minus B. Cos A minus B. Cos A minus B. Minus cos A plus B. Say yes or no? Right? So this will also be broken into two integrations only. 0 to 2 pi cos 2 tau minus t dot d tau minus 0 to 2 pi cos t dot d tau. Again you can see the same thing here. What is the time period? What is the time period here? Time period will be 2 pi by 2, that would be equals to pi, and you need to integrate for 2 time period. That means this convolution, this integration will throw 0. This integration will throw 0. So here 1 by 2, this integration is throwing 0. What will happen here? Cos t will come common. Cos t will come common. Minus sign is already there. Cos t will come common. And integrating from 0 to 2 pi d2. So that would be 2 pi. So pi is 2 and 2 is getting cancelled out. What we are getting? Pi cos t. So gt is equals to pi cos t. This is the answer. Okay. So first one was pi sin t. This is coming minus pi cos t. Next one will become plus pi cos t. So try doing it on your own. Gt will be, you are integrating for one time period. Again the time period is 2 pi only. Directly you can see time period is 2 pi only. First one remains as it is. Second one is inverted and then shifted. Right? 2 cos A cos B. What that would be? Cos A plus B plus cos A minus B. Cos A plus B. Cos A plus B plus cos A minus B. Plus cos A minus B. So that would be 2 tau minus t dot d tau. So again the same thing we are doing, 0 to 2 pi cos t dt plus 1 by 2 0 to 2 pi cos 2 tau minus t dt. So again this will throw 0. The same integration is there. The same integration is there. This will also throw 0. So what we are getting? Pi cos t. So the result of third one is pi cos t. Right? What about this one? Look, you remember one property, right? That xt convolution with yt is equals to gt. Then what will be the convolution of x of at convolution with y of at is equals to g of at, but divided by mod of a. Right? If here t is replaced with at, t is replaced with at, so this will also be replaced with at, but divided by mod of a. Say yes or no? Right? Here you cannot apply the property. T should be replaced with at, t should be replaced with at, and t should be replaced with at. Here t is t only, but t is replaced with 2t here. So you cannot apply the property here. Some people would be thinking to apply the property, but that property you cannot apply here, right? So gt remains, what will be gt? Here time period is the matter of concern. So what will be the time period here? T naught, omega naught 1. What is the value of omega naught 1? Omega naught 1 is 1. What is the value of omega naught 2? That is 2. So what will be omega naught? HCF of 1 and 2. What that would be? 1. That means time period is 2 pi. So here the time period is coming out to be 2 pi. Here I am treating cos 2t as first function. Basically I am saying that cos 2 tau remains as it is, other one is inverted and then shifted. I can treat anyone, right? I can treat anyone. I am treating this as xt and this as ht. So cos 2 tau remains as it is, this one is inverted and then shifted. multiplied with 2 divided by 2. So 1 by 2, 0 to 2 pi. 2 cos A sin B, right? 2 cos A sin B. Or 2 sin A cos B also you can treat. So sin A plus B minus sin A minus B. Sin A plus B, sin A plus B. So that would be sin A plus B plus sin A minus B. Sin A minus B. So minus 3 tau plus T. Minus 3 tau plus T dot d tau. What is the time period for this one? Time period 2 pi, right? Because omega naught value is 1, so time period is 2 pi. And what is the time period for this one? 2 pi by 3. You are integrating this for 1 time period, answer would be 0. And you are integrating this for 3 time period, again the answer would be 0. Because you are integrating from 0 to 2 pi, that means you are integrating for 2 pi window. But here this is 2 pi by 3, that means this value is 2 pi by 3, 2 pi by 3 and another 2 pi by 3, 2 pi by 3, 2 pi by 3 and 2 pi by 3, whole will be 2 pi. And if you calculate the area, positive area, negative area, positive area, negative area, positive area, negative area, 0. So whole integration is becoming 0. So what is the answer you are getting? G of t you are getting as 0. What did you understand from here? That in periodic convolution, if frequencies are different, sin omega 1t convolution with sin omega 2t, sin omega 1t convolution with cos omega 2t, cos omega 1t convolution with cos omega 2t. So any sinusoid or cosinusoid you are convolving, but they are having that different frequencies, answer would be 0. Now what will be the result of sin omega t convolution with sin omega t? So we have seen that sin t convolution with sin t was giving us minus pi cos t. This you can go back and check it, right? Now I am going to apply the property. T is replaced with omega t. T is replaced with omega t. So here also t will be replaced with omega t, but it will be divided by mode of omega. And what is mode of omega? That is omega only, right? So you remember in this manner mode of omega. So better I should write in this manner only, minus pi by mode of omega cos omega t. Okay, what was cos t convolution with cos t? That was pi cos t. So it will become pi cos t. So it will become pi by pi cos t divided by mode of omega. Sin omega t convolution with cos omega t, that was pi sin t, pi sin omega t divided by mode of omega. So these are the results. If you can remember, you should remember it. What I am saying, if you can remember, then you should remember it. Till this point in the examination hall, never ever there has been any question based on periodic convolution. They have asked convolution, but only for non-periodic signals. But periodic convolution is a good concept. I feel like that it is a good concept because here we need to find the integration as well. Like a good concept is there here also. If I see smartly that it is being integrated over 2 time period, then answer could be 0. So here smartness can be checked. So what I feel is that although it is not important because till now questions have not been asked, but if you can remember, then you can remember these results. But at least remember this result, that if two different frequencies are being convolved, then surely the answer would be 0. In sinusoid and cosinusoid, if two different frequencies, sinusoid and cosinusoids are being convolved, then answer would be 0. Sin t convolution with sin t. Now, what is the way to remember? I am telling a way. What we are studying? Convolution. So convolution starts from C. Convolution starts from C, and cos also start from C. If same are there, answer would be cos. If same are there, answer would be cos. Sin same, answer is cos. Cos same, answer is cos. Sin cos different, then answer would be sin. Okay. Now here there will be a negative sign. How will you remember? Look, sin is there, both guys are sin, but answer is saying that I will be cos. So there will be a fight in between them, right? They will not be happy that sin and sin are being convolved and the answer is saying that I will be cos. So this is something that sin will not like, that we two guys are being convolved and here answer is being thrown as cos. So sin guys will not like it, that's why they will give the negative sign. cos cos, cos happily, sin cos. So something different has to be there. No, for same cos would come. Convolution. Sin will say I will also come in the answer. So sin cos, the answer will be sin. Okay, and there is no negative sign because they will be making a partnership that for same I am coming at the output, for different at least I should come at the output, and there should be no negative sign, there should be no fight. Here same was there, cos will say I will come at the output, but sin will fight that V2 convolved, but answer is cos, so I will put a negative sign. So this is the way to remember. If you can remember, then you can remember. If you don't want to remember, then at least you will be able to do the derivation in the examination hall if some question is asked. Well and good. Okay, so if you want to write down this trick anywhere, then you can write down. Otherwise, in any way, if you want to remember, you can remember. Try solving this question. Xt is even, having half wave symmetry. It is periodic with 1 radian per second. Yt is odd, having half wave symmetry, periodic with 2 radian per second. Periodic convolution is done. Xt convolution Yt, that is equals to Gt. Which of the following statement is true? Okay. So what is Xt? Xt is even and having half wave symmetry. What does that mean? Xt is even and having half wave symmetry. Fundamental frequency is 1 radian per second. What does that mean? That is, it will have cosinusoids. Half wave symmetry is there, that means DC is 0, and along with that it will only have omega naught, 3 omega naught, 5 omega naught, and so on. Say yes or no. All good? So let's start. What will be your Xt? So Xt will be A1 sine. What is the value of omega naught? That is 1. Not sine. Why I am saying sine? Cosine. A1 cos omega naught t plus A3 cos 3 omega naught t plus A5 cos 5t plus and so on. So 1, 3, 5, 7 in that manner we will keep on going. What about Yt? Yt is odd, having half wave symmetry. Omega naught is 2 radian per second. Right? Odd means sinusoid. Half wave symmetry means omega naught, 3 omega naught, 5 omega naught, and certainly DC is also 0. Odd also says DC is 0, and half wave symmetry also says that DC is 0. So what is your Yt? Till this point you would have understood the answer, right? What would be your Yt? Yt would be B1. What is the value of omega naught here? 2 radian per second. So this will be 2, 6, 10 in that manner. So B1 sine 2t plus B3 2, 6 sine 60 plus B5 sine 10t in that manner. Then you do the convolution. Gt is Xt convolution with Yt. So cos t will be convolved with all these things. Then cos 3t will be convolved with all these things. Then cos 5t will be convolved with all these things. I hope you remembered it. Xt plus Yt convolution with h1t convolution plus h2t. What will be the answer? Xt convolution h1t plus Xt convolution with h2t plus Yt convolution with h1t plus Yt convolution with h2t. So here what we will see? All these are in addition, these are also in addition, both are being convolved. That means Xt convolved sine 2t 0. Sorry, cos t convolved sine 2t 0. Cos t convolved sine 60 0. Cos t convolved sine 10t 0. Why is that so? Because different frequencies. Then cos 3t convolved with sine 2t 0. Cos 5t convolved with sine 60 0. Cos 5t convolved with sine 10t 0. Basically always different frequencies would be there, no? Because here the frequencies would be 1, 3, 5, 7, 9 and so on. And here the frequencies would be 2, 6, 10, 14 in that manner. So these will be always even and these will be always odd. So both number will never be the same. And if both numbers are never same, what does that mean? That always the convolution will be 0. So Gt is equals to 0. This is the answer. That's it. Okay, so gt is equals to 0. Well and good. Let's go to this one. Which of the following statement is true about periodic convolution? Okay, so periodic convolution of even and odd periodic signal is odd signal. Periodic convolution of odd and odd periodic signal is even signal. In that manner you need to check. So even and odd, take any example. Even and odd, even convolution with odd, what you are getting? Sin t. So even convolution with odd is odd only. Even convolution with odd is odd only. Next one, odd convolution with odd. Odd convolution with odd, what you are getting? Same means cos, but both will fight negative sign. So odd convolution with odd is giving you even. Odd convolution with odd is giving you even. Then even convolution with even will give you even only. Even convolution with even is giving you even only. So all true, right? All true. So here you can see all true, odd, even, all true are there. Okay, and consider all the signal periodic with the same fundamental frequency. Basically, here fundamental frequency should be same, omega naught, omega naught, omega naught, omega naught, omega naught, omega naught. Otherwise, I could have said that, sir, cos t convolution with cos 2t. This is also even, this is also even. What is the answer? 0. But this we don't need to see, right? Fundamental frequency should be same. So all true. Now there is a property. Why we studied all these things? Because finally there was a property. Again, this property makes no sense. So we are not going to spend time on this. What does it say? That if you are doing the convolution of xt convolution with yt, then your g of n will be equals to cn dot dn. Just you need to multiply with the time period as well. And this will be applicable only for having same fundamental frequency. Again, if the fundamental frequency is different, then again you will take the HCF. Then with respect to that HCF, you will make the fundamental frequency. With respect to that HCF, you will make the harmonics, and then you will apply this particular method. Okay, and in place of T naught, what you will put? You will put the LCM of T naught 1, T naught 2. Nowhere it will be used, so we are not going to spend the time. Like previously on some questions we spend the time, but here we are not going to spend any time on this. Just I am telling you there is a property. What was the property for? What was the property for multiplication? So in the multiplication, what was happening? Convolution. In the multiplication, convolution was happening, right? So your g of n was cn convolution with dn. Here what is the scene? Convolution is there. So here multiplication is happening. Just another point is that it will be multiplied with t naught as well. Right? What is t naught? Time period. So you can verify with anyone, like you do cos t convolution with sin t is equals to sin t. So you find out the you make x t is equals to cos t. So you can find out c1 c of minus 1. Here you can find out d1 d of minus 1. Then you remember the result already, that is sin t, and then you do this process, you will get the same answer. But not a matter of concern. This is not a matter of concern for us, because we are never going to apply these in our examination. If they want to frame a good question, they will frame a question like this, and this concept, this slide, if I am able to remember, I will be able to answer all the questions. Till now there has not been any question, but this is a good concept. I feel from periodic convolution they can frame a very good question. So that's it about this video. We have seen the properties which are not important at all. Why we spend so much time on this lecture is that I just wanted to tell you that if you have already studied these properties, then these properties are not that straightforward. There is something wrong about these properties, and that we have seen here. What is wrong about these properties? How they are performing? That we have understood. The first property that we studied, e to the power j m omega naught t, that was important. Nothing else is important. All good? Let's go to the next lecture. Next lecture will be last lecture. So whatever that is left, that we are going to cover. Next lecture will be of roughly around, I guess, 30 minutes only. So 30 minutes are left only. So in that 30 minutes, whatever that is left, that we are going to cover. Drichlet condition is left, Gibbs phenomena is left, and that polar form of Fourier series, that is also left. Again, not very important, but you should know it. So in 30 minutes, we will be able to cover that particular part as well. Okay. So I hope you enjoyed this one, and thank you very much. Hi everyone. So this will be our last video on Fourier series. So in this video we will see three topics. First one is the polar form of Fourier series. Second one we will see the Drichlet condition, and third we will see Gibbs phenomena. So these three topics we are going to cover. So before that there is a note, cos omega t minus theta. This is written, okay. How you can open it? Cos a minus b, that would be cos a cos b, cos a cos b plus sin a sin b. And how you can open this? Sin a minus b, sin a cos b minus cos a sin b. So what I mean to say is that this signal looks like it is cosinusoid. This signal looks like it is cosinusoid, but actually it is cosinusoid and sinusoid together. This signal looks like it is only sinusoid, but actually it is sinusoid and cosinusoid together. This is the only conclusion. That's why I wrote it down. Cos omega t, if there is another phase added, this angle could be anything. It could be alpha, beta, pi by 3, pi by 2. If there is another phase, then this actual signal is made from sinusoid and cosinusoid with that particular amplitude. This will be some amplitude, phase will be constant, so this will be some amplitude. So it feels like it is cosinusoid, but it is actually cosinusoid plus sinusoid. It feels like it is sinusoid, but it is actually sinusoid plus cosinusoid. That's it. Okay. So have we studied trigonometric Fourier series? Yes. This was the trigonometric Fourier series. Xt is equals to DC value and cosinusoid and sinusoids of omega naught, 2 omega naught, 3 omega naught, and so on frequencies. Now what I am doing, what I am saying is that my xt is real. What I am saying, my xt is real. So if xt is real, then an and bn are also real. If xt is real, then an, bn and c naught are also real. So what I am doing is that I am replacing my an with Rn cos theta, and I am replacing my bn with minus Rn cos theta n. So I am replacing my bn with minus Rn sin theta n. Why I am doing so, you will understand. Okay, why I am doing so, you will understand that. So if I replace this particular thing, so from here what you can see, what is your tan theta n? Tan theta n is minus bn by an. So what is the value of your theta n? That is tan inverse minus bn by an, and tan inverse has the ability of taking out the negative sign. So this negative sign will come out, bn by an. This is the value of theta n. This is the value of theta n. Along with that, from here I can see, one thing I can see is that an square plus bn square is equals to Rn square, right? This I am calling as equation 1, this I am calling as equation 2. So if you square on both of the sides, an square is equals to Rn square cos square theta n, bn square is equals to Rn square sin square theta n. If you add both of the equations, then what you will get? Rn square, then common will be cos square theta plus sin square theta. So Rn square will be common, then cos square theta plus sin square theta will be 1. So Rn square is equals to an square plus bn square. So this also we have seen, right? This is very simple. Just square and add both of them. So Rn square is equals to an square plus bn square, and this also we have seen. Now let's put this into this equation. Let's put an and bn value into the trigonometric Fourier series coefficient. Okay. So xt is equals to dc remains as it is. dc remains as it is. N is going from 1 to infinity. Value of an is Rn cos theta n, then cos n omega naught t. What is the value of bn? Bn value is minus Rn sin theta n. Minus Rn sin theta n sin n omega naught t. Cos a cos b minus sin a sin b. Rn can come common. Rn is common here. N is going from 1 to infinity. N is going from 1 to infinity. Rn is common. Inside what is there? Cos a cos b minus sin a sin b. What is the formula? Cos a plus b. Cos a plus b. And there you go. This is known as the polar form. Polar form of xt. So, okay. This is the polar form of Fourier series. Polar form of Fourier series. Here what is the relation? Rn square is equals to an square plus bn square, and theta n was nothing you need to mug up, okay? Nothing you need to mug up. If any question is coming, that is pretty rare, but if any question is coming, you will be able to do this analysis, that's it, nothing else. Well and good. This and this. Okay. And if someone asks you what is the power of xt, can you tell me the power? Let's write down the xt. Xt will be c naught plus, put n equals to 1. So r1 cos omega naught t plus theta 1 plus r2 cos 2 omega naught t plus theta 2, and in that manner it will keep on going. So by looking at this expression, will you say that only cosinusoid components are present? No, you will never say that. By looking at this expression, you will never say that only cosinusoid components are present. Why is that so? Because this is the addition of cosinusoids and sinusoid. Cos omega t minus theta or cos omega t plus theta, whatever it would be. So cos omega t plus some phase. So it is sinusoid as well and it is cosinusoid as well. So this expression is saying that it is having sin omega naught t as well and it is having cos omega naught t as well. Both are there. So just by looking at this expression, you cannot say that only cosinusoids are present. Sinusoid is also there. What about the power? Power of xt. Power of xt is c naught square dc square plus, what is the power of a cos omega t plus theta? All these are orthogonal to each other. Yes, right? These two are orthogonal to each other because of the different frequency. This is omega naught, this is 2 omega naught. So they are orthogonal. If orthogonals are there, so I can add up the power individually. What is the power of this particular thing? That is a square by 2. Right? No matter whatever the phase is, power is a square by 2. So r1 square by 2. Here I am not putting the mode. When I wrote down the power, I was putting mode of an square plus mode of bn square divided by 2. In that manner, I was putting the mode. Why I am not putting the mode? Because Rn will be real only. Rn is not going to be imaginary. Rn will be real. Are you able to understand the point? Because An and Bn are real, no? An is real, Bn is real, right? And Rn square is An square plus Bn square. Because xt is real. If xt is real, then An, Bn are real, then Rn is also real. So that's why I am not putting mode here. R1 square by 2 plus R2 square by 2 plus R3 square by 2, and in that manner it will keep on going. So what is the power? C naught square plus summation n goes from 1 to infinity Rn square. This is the power. Rn square by 2, sorry. Rn square by 2. This is the power of xt. How you can relate it? C naught square summation n goes from 1 to infinity an square plus bn square divided by 2. This is the power we wrote. What is the value of this particular thing? That is equals to Rn square. So what is the power? N goes from 1 to infinity Rn square by 2. So this is how it can be related as well. Okay. So we have seen a lot of formula of power. So let's write down all the formula of power. So power. There is no comment on xt. Okay. If there is no comment on xt, xt could be anything. It could be real, it could be imaginary, or it could be complex as well. Then what is the formula of power? So power of xt would be, first thing, basic formula 1 by t naught mod of xt square dot dt, right? Then what is the other formula? Summation n goes from minus infinity to infinity mod of cn square. What is the other formula? That c naught square plus summation n goes from 1 to infinity mod of an square plus mod of bn square divided by 2. So these are the formula for real, imaginary and complex. Now if xt is only real, xt is purely real. Second case is, this is the first case. What is the second case? xt is purely real or purely imaginary. Then what you can do? You can break this one down, right? So power of xt, first the general formula 1 by t naught mod of xt square dot dt t naught, then mod of c naught square, here also mod of c naught square, mod of c naught square, then twice of summation n goes from 1 to infinity mod of cn square. Okay, and what about this one? This would be the same only, C naught square summation n goes from 1 to infinity mod of an square plus mod of bn square divided by 2. Along with that, you can write down one more relation, that mod of Cn is equals to this, and then that is equals to mod of an square plus mod of bn square divided by 2. Here let's do the square. Actually it was under root, so I have replaced the under root. Okay, let's not replace the under root because under root will be coming only on this part, not on the 2 part. So let's not replace the under root. This was the relation, right? I hope you know all these relations. So till this point we have already seen. Now if xt is only real, if xt is purely real, because most of the time, like 99% of the time, you will have to deal with the real signals only. When you go into the industry or wherever you go, we will see real signal, real world signal only we will see. So most of the time we have to deal with the real signals. So if it is real, if xt is real, then what will be the power of xt? Power of xt would be 1 by t naught. T naught. I don't need to put mod here. Why is that so? Because square will take care. Why do I put the mod here? Because xt could be imaginary. That's why I put the mod. Then this formula remains as it is. Here I have to put mod of Cn. Why is that so? Because if xt is real, does that mean that Cn will also be real? No. If xt is real, then Cn will be complex. Or it could be imaginary, it could be anything. Basically, I cannot comment that if xt is real, then Cn is also real. That I cannot say. Take any example. Sinusoid. What is the value of C1? Minus 1 by 2g. What is that? That is imaginary. Or how you can see it? If xt is real, then what is the value of Cn? Cn is an minus j bn by 2. If xt is real, then an is also real, bn is also real. That means this is real, and then there is a j. That means Cn will be complex, or it could be real, or it could be imaginary as well. Because what if bn is 0? If bn is 0, then an will be real. If an is 0, then Cn will be imaginary, and if an and bn both are non-zero, then Cn will be complex. So if xt is real, then you cannot comment anything on Cn. So this formula remains as it is. If xt is real, then this formula remains as it is. Nothing you can do about this formula. This formula remains as it is. Just you can break down this formula into this one if xt is real. Along with that, what about this formula? This formula also remains as it is. And just the point what you can do is that if xt is real, then this value will also be real. So you don't need to put the mod here. Basically, C naught, if xt is real, then dc value will surely be real. We don't need to put the mod. And if xt is real, then an and bn are also real. From here, what I can say, an and bn are also real. Then you don't need to put the mod. An square plus bn square by 2. You can avoid the mod. Along with that, what formula you can write down? That C naught square summation n goes from 1 to infinity Rn square by 2. Well and good. So this formula also you can write down. And Rn square is equal to an square plus bn square. So it feels like it is complex, but nothing is complex here. If you have the clear concept, then it is very, very easy. Xt can be written in 3 forms. Summation n goes from minus infinity to infinity Cn e to the power j n omega naught t. That is equal to, another form is C naught plus n goes from 1 to infinity an cos n omega naught t plus bn sin n omega naught t. The third form just now we have studied, that goes for only when xt is real, that is C naught plus n goes from 1 to infinity Rn cos n omega naught t plus some phase. Okay. Why we are using this advantage of using polar form over trigonometric form? So what did I tell you? Mostly you will have to use real signal only. Mostly xt is real signal. Okay. Most of the times xt is real signal. Now if I say, and if I tell you that value of a1 is 0, what did I say? That value of a1 is 0. So can you say that, sir, 100% there will not be any frequency component of omega naught in xt? Let me repeat the statement. What did I say? That a1 is 0. So you will say that, sir, in the xt there is no information of omega naught frequency. Can you say that thing? No. Because if a1 is 0, then who knows B1 can be non-zero. A1 is 0, B1 is non-zero, then certainly there is some information about omega naught. Are you getting this point? But if I say R1 is 0, if I say R1 is 0, that means certainly I can tell that omega naught component will not be there. So there is no component of omega naught frequency in xt. Are you able to understand this point? If I write down that trigonometric form, then I have to say both A1 and B1 are 0. Then only you will say that, okay, omega naught frequency is not there. But if I say R1 is 0, in polar form, if I say R1 is 0, then you will say that, sir, okay, if R1 is 0, that means there is no frequency component of omega naught. So it is giving you a better picture, right? Clearer picture, that only one component you tell, only one coefficient you tell, that R1 is 0, then job is done. There is no information about omega naught frequency. But in trigonometric Fourier series, you have to give two information, that A1 is also 0, B1 is also 0. So this is the advantage of polar form. That's why we denoted the polar form. Although till this date, there has been no question on the polar form. Who knows, they may ask. So that's why we studied it. Okay. So gives a clear picture. What I am writing shows the clear picture of the, shows a clearer picture of absent frequency component. Okay. And if you want to write down anything else, then you can write down here. This space I am keeping for you guys. So if you want to write down anything else, you can write down here. Okay. So it is showing a clearer picture of absent frequency components. Well and good. Now we are going to study about Drichlet condition, and Drichlet conditions tells the convergence of Fourier series. What is the meaning of convergence of Fourier series? Convergence of Fourier series means Fourier series exist. Convergence means existence. That's it. What is the meaning of convergence? Convergence means existence. Okay. Now two statements I have written, that Fourier series of a periodic signal surely exist if they follow, surely exist, or I can say surely converge if they follow that Dirichlet condition. And then second statement I have written, Fourier series of a periodic signal may or may not exist if they don't follow that Dirichlet condition. What did you understand from that? So if I tell you a statement that if you follow PrepFusion's content, then you will be qualified in the gate examination. If you follow PrepFusion content, then you will be qualified in the gate examination. But if you don't follow PrepFusion's content, that doesn't mean you are not going to qualify. Who knows, you are following the content of someone else, then you can qualify. Are you able to understand this point? So what Drichlet is saying? Drichlet is saying that if you follow my conditions, then surely your Fourier series will exist. But if you don't follow my condition, then it might happen that it is existing, it might happen that it is not existing. Are you able to understand this point? That means Drichlet conditions are sufficient but not necessary, for the convergence of Fourier series. Are you able to understand this point? That means if you are following the Dirichlet condition, then certainly your Fourier series will exist. But if you are not following the Dirichlet condition, then your Fourier series may or may not exist. Is that point clear? Okay. So let's start studying about the Dirichlet conditions. So what is the first Dirichlet condition? That your periodic signal, here by default we are talking about all the periodic signal. If xt is not periodic, then there is no meaning of Fourier series. So we are talking about periodic signal. So xt is already periodic. So by default we are talking about periodic signal only. So if xt is not periodic, then there is no meaning. So if xt is periodic, then xt should be absolutely integrable in one time period. What is the meaning of absolutely integrable? That in one time period, mode of xt dot dt should be finite, or you can say less than infinity. Finite or less than infinity. So is this signal periodic? Yes. What is this signal? Xt equals to tan t. Is this signal periodic? Yes. Is this signal absolutely integrable in one time period? This time period I can take minus pi by 2 to pi by 2. Is this absolutely integrable? You cannot say just by looking at the graph. I have told you this thing when we were studying about absolutely integrable signal. I told you just by looking at the graph, you can never tell whether it is absolutely integrable or not. Why is that so? Because if you remember this example, I guess this was the example only. We took one example where it felt like that it was not absolutely integrable, but it was integrable. I guess it was 1 by t u of t minus 1. I guess this was the example only. So here it felt like that it is not absolutely integrable, but it was actually absolutely integrable. Yeah, this was the example only as far as I remember, because ln t that goes from ln t will go from 0 to 1. No, I don't think this was the example. There's some different example was there. So the signal was going to infinity, but there we got to know that if you have followed the content previously, then you would know what example I am talking about. So there what was happening, the amplitude was going to infinity, but still that was absolutely integrable. So just by looking at the graph, you can never tell whether the signal is absolutely integrable or not. You have to do the calculation. So let's do the calculation. In one time period, I need to find mod of xt dot dt. So how I can write it down? Between minus pi by 2 to 0. What I need to do? I need to take the mode of this. This is negative. Do you remember how to open mode of x? It would be x if x is greater than 0. It would be minus x if x is less than 0. So between minus pi by 2 to 0, this is negative, no? Tan t is negative. This tan t is negative. Between minus pi by 2 to 0, this tan t is negative. So how it will open? It will open with the negative sign. And from 0 to pi by 2, tan t is positive, so it will open with the positive sign. What is the integration? Minus ln sec t mod of ln mod of sec t. This minus sign is already there. Minus pi by 2 to 0. Or what I can do, I can eat up this negative sign. And then I can interchange the limit from 0 to minus pi by 2. Plus here ln sec t 0 to pi by 2, right? So what we are getting? What is the value of sec pi by 2? That is 0, right? Sec pi by 2. Sec pi by 2 is equal to 1 by cos pi by 2. What is the value of cos pi by 2? Cos pi by 2 is, okay, sorry, that is infinity, because cos pi by 2 is 0, so this will be infinity. Minus sec 0 is 1, right? Because sec 0 is equal to cos 0 is 1 only, so sec 0 is 1. Plus sec has the ability of eating up the negative sign, that's why I took plus pi by 2 here. So sec pi by 2, what is sec pi by 2? Sec pi by 2 is infinity, so ln infinity minus ln 1, then here also ln infinity minus ln 1. So ln 1 and ln 1 is getting cancelled. What is the value of ln infinity? That is infinity only, and this is also infinity, so what is the answer? Infinity. That means it is not finite. So what we are getting here, for one time period, mod of xt dot dt is going towards infinity. That means Fourier series doesn't exist. So even if the signal is periodic, but it was not absolutely integrable, that's why Fourier series is not existing. Well and good. Okay, let's go to the next condition. Xt should have finite number of maximas and minimas in one time period. So this is a very good property. What it is saying, it should have finite number of minimas and maxima. Xt is already periodic. Okay, xt is already periodic. Then what it is saying, it should have finite number of maximas and minimas in one time period. So what is xt? This is your xt. Xt is defined as between 0 to 2 it is gt, between minus 2 to 0 it is gt plus 2, between 2 to 4 it is gt minus 2. What you will write here? It will be gt plus 4 between minus 4 to minus 2. In that manner it will keep on going. Or what you will write here? It would be gt minus 4 between 4 to 6. Say yes or no, right? So first you let me know, is xt periodic? How will I check it? How will I check it? Let's do x of t plus 2, because I see that there is a gap of 2. So let's write down x of t plus 2. What will be your x of t plus 2? What will be your x of t plus 2? So in place of this, here in place of t, what I am putting? T plus 2. So g of t plus 2, it will become t plus 4. So this will become g of t plus 4. And here what I will write down? I am talking about this one, okay? In place of t, I am putting t plus 2. So this becomes g of t plus 4. Okay, and here what I will write down? Minus 2. Minus 2. In place of t, I need to write down t plus 2 less than 0. So what you are getting? Subtract minus 2 from all the sides. So what I will be getting? Minus 4, 2 to minus 2. So between minus 4 to minus 2, it is gt plus 4. Between minus 4 to minus 2, it is gt plus 4. So it is matching. Let's do it more. Here in place of t, what you will put? T plus 2. In place of t, what you will put? T plus 2. T plus 2, 0 to 2. From 0 to 2. So what you are getting? Between minus 2 to 0. Then here in place of t, you put t plus 2. What you are getting? gt t plus 2. It is going from 2 to 4. 2 to 4. That means it is going from 0 to 2. So what do you see here? This will also go till infinity. This is also going till infinity. What do you see here? The same kind of graph is being repeated. gt plus 4 minus 4 to 2. gt plus 4 minus 4 to 2. Next gt plus 2 minus 2 to 0. gt plus 2 minus 2 to 0. Next gt 0 to 2. Next gt 0 to 2. In that manner, this will also be repeated. What does that mean? That your x of t plus 2, and this is going till infinity, no? Infinity, and upper side as well, it is till minus infinity, right? So from here, what I get to know is that this is the scene. What does that mean? It is periodic with t naught is equals to 2. Okay. Now what the property was saying, so this was the first thing that we have seen, is it periodic or not. Now we need to see whether the Fourier series will exist or not. So what it is saying, that xt should have finite number of maximas and minima in one time period. So what is my matter of concern? My matter of concern is only one time period. What is my matter of concern? Only one time period. Only one time period. This is my matter of concern. That means my matter of concern is between 0 to 2. So between 0 to 2, your xt is equals to gt. Between 0 to 2, your xt is equals to gt. And what is gt? gt is between 0 to 2, it is some sinusoid function, otherwise it is 0 only. What does that mean? I need to draw the graph of gt. What I need to do? I need to draw the graph of gt. And it will follow between 0 to 2 only. Although after that gt is 0. Although after that gt is 0 or whatever it is, I don't care. After that gt is 0 or whatever it is, I really don't care. But I just need to make the graph of gt between 0 to 2. So your gt is equals to sine pi 2 pi by t. Sine 2 pi by t. And in time window from 0 to 2. So let's not start from t equals to 0, because it will be sine infinity. So this angle we cannot actually comment. So let's start from t equals to 2. So at t equals to 2, what is the value? If you put t equals to 2 here, sine pi will be 0. So at t equals to 2, value is 0. Then where I will go? I am going from 2 to 0. I am going from 2 to 0. What I am doing? I am putting the gt versus t I am doing, no? So value of t I am putting from 2 to 0. Next what I will do? I will put the value of t as 3 by 2. What I am doing? Although I should put the value as 1.999999, but I am putting 3 by 2. So what it will be? Sine 2 pi upon 3 by 2. What I will get? Sine 4 pi by 3. So this value is negative, right? Sine 4 pi by 3 will be negative, because it is going in third quadrant. Sine 4 pi by 3. Sine 4 pi by 3. So this is pi, sine 4 pi by 3 will be somewhere here. So value is negative. So basically it started from here, then it became negative. Then again it will be 0. Where it will be 0? When t is equals to 1. Because sine 2 pi is 0. So again it will be 0 at t equals to 1, right? So let's make it more near. Now what do you see? You are going from 2 to 0. That means this angle I am calling as theta. What I am doing? 2 pi by t I am calling as theta. 2 pi by t I am calling as theta. So where theta will go? Theta will go from pi to infinity. Yes or no? Theta will go from 180 degree to infinity. That means theta will take infinite number of values. Theta will take pi as well. Theta will take pi by 2 as well. It is going from pi to infinity. Okay, it is going from pi to infinity. So theta will take pi. Theta will take 3 pi by 2 as well. Theta will take 4 pi. Theta will take all these values. Right? It is going from pi to infinity. Are you able to understand this point? Theta is going from pi to infinity. That means theta will take all these values till infinity. If I draw the graph of sinusoid, so sinusoid has a maxima at pi by 2. It has a minima at 3 pi by 2. Then again it will have a maxima at 5 pi by 2. Then again it will have a minima at 7 pi by 2. Sorry, plus 7 pi by 2. Is similar happens at negative side as well, but our matter of concern is positive side. So if it is going from pi to infinity, your angle is going from pi to infinity. That means it will have 3 pi by 2, 5 pi by 2, 7 pi by 2, and then again 9 pi by 2, then again 11 pi by 2. So infinite times of angle. That means infinite number of maxima and minima would be coming. Are you able to understand this point? I made the graph of sine 2 pi by t. What I need to make? I need to make the graph of sine 2 pi by t. But the graph is not my matter of concern. Matter of concern is that how many maxima and minima I will be getting. So what did I do? I started from t equals to 2. There I got to know that my value is 0. Then I know that I need to go from 2 to 0. If I go from 2 to 0, then my angle is going from pi to infinity. That means whatever the angle is there between pi to infinity, here next 3 pi by 2 will come, or any angle like 4 pi by 3 will come, or any angle 7 pi by 2 comes. There are infinite number of angles, and add those infinite number of angles, there will be infinite number of maxima and minima. So this kind of graph you will be getting, right? What kind of graph? This kind of graph, like it goes like this, and then a lot of maxima minima, a lot of maxima minima. In that manner it is keep on going. Are you able to understand this point? So what is my matter of concern? My matter of concern is between 0 to 2. So what will be the graph of xt? This is the graph of gt I have made. So this kind of graph of gt I will make, and here infinite number of maxima and minima you will get. And minima you will get. But my matter of concern is not gt. My matter of concern is xt, because I need to tell all these things in xt. So how will the graph of xt look like? This is how the graph of xt will look like. What I mean to say is that between 0 to 2, this kind of graph I am getting. Between 0 to 2. Look, there is minima, then maxima, minima, maxima, but here infinite number of minima and maxima. Here a lot of minima, maxima are coming. So infinite number of minima and maxima. And why they are infinite in numbers? Did you understand this point? Because we are going from pi to infinity. That means there are infinite number of angles, and at infinite number of angles there will be infinite minima and maxima also. And what is the property of xt? That it is being repeated after every 2 seconds. So in 2 seconds, whatever that is happening, the same is happening for next 2 seconds, the same is happening for next 2 seconds. Here also the same thing is happening, and here also the same thing is happening. And what Drichlet is saying? Drichlet is saying that in one time period, if you are having infinite number of maxima and minima, that means Fourier series does not converge, or Fourier series doesn't exist. Fourier series doesn't exist. So it was a good example. It also cleared some mathematics. It also cleared some concept of your time period and all these kind of things. So it was a good example. This requires mathematics as well. Although I could have directly made the waveform and I would have said that there are infinite number of maxima and minima, but actually you should know what kind of signal we are talking about. This kind of signal we are talking about. If there is a signal kind of this, then the Fourier series will not exist. Well and good. Let's go to the last one. So this is the third condition. What it is saying? That xt should have finite number of discontinuities within one time period. Furthermore, each of these discontinuities should be finite. What is the meaning of this? So one time period, this is one time period. Do you know what is discontinuity? Yes. x of 0 plus and x of 0 minus both are not equal. That means if both are not equal, what does that mean? That it will not be continuous at t equals to 0, right? If I need to find at t equals to random point t1, so x of t1 plus and x of t1 minus, if both are not equal, that means it is not continuous. So basically here it is not continuous. Wherever it is not continuous, when you differentiate, impulses will come. So if you differentiate, here impulses comes, right? Here impulses come. So they are not continuous at these points, But in one cycle, it is not continuous only at one point. It could be discontinuous at 2 point, it could be discontinuous at 3 point, it could be discontinuous at 4 point, it could be discontinuous at 1000 point. Although in one cycle it is discontinuous only at 1 point, right? Only at 1 point it is discontinuous. Along with that, these discontinuities must be finite. What does that mean? Here it is going from a to minus a. So discontinuity is of 2a. Discontinuity, it is going from a to minus a. Basically, you can say discontinuity is of minus 2a, or you can say it is of 2a. So that is finite. Basically, the length is finite. The length of discontinuity is finite. So it is having finite number of discontinuities. Also, the length of discontinuity is also fine. Sorry, what I mean to say, it is having a finite number of discontinuities. Along with that, the length of discontinuity is also finite. That means Fourier series will converge here. Okay, so Fourier series converges. Are you able to understand this point? Fourier series converges, and we have find out the Fourier series for this one. So that means Fourier series converge. In one time period, number of discontinuities should be finite, and the length of discontinuity should also be finite. The length of discontinuity is also finite. But what about this example? What we are doing in this example? That it is periodic with 2 seconds. Okay, it is periodic with 2 seconds. It is periodic with 2 seconds. So signal is periodic. But what is happening? For some time the amplitude is a, then the amplitude became a by 2, then amplitude became a by 4, then amplitude became a by 8. So this is how the amplitude is going: a by 2, a by 4, a by 8, a by 16, and in that manner it will keep on going, a by 2 to the power n. In this window only. In this window of 2 seconds, this is how the amplitude is going. That means here it is discontinuous, because just before the value is a, after that value is a by 2. Here also it is discontinuous, just before the value is a by 2, after that the value is a by 4. So in that manner, how many discontinuities would be there? Infinite number of discontinuities would be there, right? So how many discontinuities are there? Infinite discontinuities. Infinite number of discontinuities. What I will write down? Number of discontinuities is infinite. Number of discontinuity is infinity. But the length of discontinuity is finite. Length of discontinuity is finite, right? What is the length? Here the length of discontinuity is a by 2. Here a by 4. Here a by 8. So length is finite. But if the number of discontinuities are infinite, that means no Fourier series. Fourier series doesn't converge. Fourier series doesn't converge. Just only if we are not following only one condition, that means Fourier series doesn't converge. Are you able to understand this point? Here there was one discontinuity only, and the length was also finite. So I was fine with that. But here the length is finite. I am fine with the length, a by 2, a by 4, a by 8. But the number of discontinuities are infinity. So I am not fine with that. That means Fourier series does not converge. Done? Okay. But there is a exception, and this is not exception. This just tells our statement. What was the statement? Let's go to the first page. What I wrote here: Drichlet conditions are sufficient but not necessary. Okay. That means what if someone is not following these conditions? Still the Fourier series may exist. Why is that so? Let's see this example. So between minus t naught by 2, t naught by 2. First you let me know, is it absolutely integrable? Yes, it is surely absolutely integrable. Minus t naught by 2 to t naught by 2 a delta t. Although I need to take the mode, but it is positive only. So a delta t. What will be the value? A. That means it is finite, absolutely integrable. First condition is satisfied. finite number of maxima and minima should be there, only one maxima is there. Basically, amplitude shoots up and then goes down. So finite number of maxima and minima are also there. So first condition is satisfied, second condition is also satisfied. Third condition, it should have finite number of discontinuities in one time period. So between minus t naught by 2 to t naught by 2, only one discontinuity is there. This is discontinuity, right? Because here the amplitude is 0 and then suddenly the amplitude is going to infinity. A is the area. What is the amplitude? Amplitude is going to infinity. So amplitude was 0, then suddenly it is going to infinity, then again it became 0. So there is discontinuity here. So how many discontinuities are there? One discontinuity is there. So one discontinuity. Number of discontinuity is 1. Continuity is 1. But what is the length of discontinuity? From 0 to infinity is going, and then infinity to coming, it is coming back to 0. So what is the length of discontinuity? Length of discontinuity. What is the length? That is infinity. So here what it is doing? Not satisfying Drichlet condition. Drichlet condition not satisfied. And if it is not satisfying Drichlet condition, what does that mean? Fourier series should not converge. But we know that Fourier series converges because I told you to remember this answer. So what did I tell you in the first page? What did I tell you? It is not necessary that if you are not following the Dirichlet condition, if you are not following the content of PrepFusion, then it doesn't mean that you are not going to qualify the gate examination. You can qualify the gate examination by self-study as well. So if you are not following the Dirichlet condition, that doesn't mean your Fourier series may not exist. It may exist as well. So it is existing as well. Okay. So I hope this is clear. In the examination, only some statement can come and they will ask you which of them will tell the Dirichlet condition. So what all are the Dirichlet condition? Absolutely integrable. Second, should have finite number of maxima and minima. And third, should have finite number of discontinuities. Also the length of discontinuity should also be finite. Is that clear to you? Just revise it once. Within 2 to 3 minutes you will be able to revise it. So this is the end of Dirichlet conditions. Next we need to study about Gibbs phenomena. So there are a lot of statements written. You will not be able to understand the statement. So let's see the example. Right? So let's see the example. So this was your xt, right? Here is it absolutely integrable? Yes, absolutely integrable. Absolutely integrable. Integrable. Second condition, is it having finite number of maxima and minima? Yes, maxima and then minima, maxima and minima. So in one time period, finite number of maxima and minima. Third condition, it should have finite number of discontinuities in one time period. Yes, it is having finite number of discontinuities. One discontinuity, second discontinuity. So it is having two discontinuities in one time period. In this time period, it is having two discontinuities, right? So it is having finite number of discontinuities and the length of discontinuity is also finite. Absolutely integrable is there. Finite number of discontinuities is also there. Finite number of maxima minima is also there, and the length of the discontinuity is also finite. What does that mean? That it is satisfying all the Dirichlet condition, and if it is satisfying Dirichlet condition, then certainly Fourier series exist. So Fourier series converge. Converge. Right? And can you tell me about the frequency component of this one? This is even, and it will, if I subtract that DC value, then it will have the half wave symmetry as well. If I subtract that DC value, it will have the half wave symmetry as well. This is known as hidden half wave symmetry, because if you subtract the DC value, then it will have the half wave symmetry, right? As of now, there is no half wave symmetry, but if you subtract the DC value, it will have the half wave symmetry as well. Okay. So what will be my xt? It is having some DC value, and only it will have cosinusoids. So a1 cos omega naught t plus a3 cos 3 omega naught t plus a5 cos 5 omega naught t. In that manner, a7 cos 79 omega naught t and in that manner A79, sorry, basically 1 3 5 7 all the odd number would come. So 79 harmonics will also come. This is 79th harmonics, this is 5th harmonic. So there are infinite number of harmonics, but only odd harmonics are there. Okay, so there was a physicist, okay, there was one physicist who was having these signals. There was one guy who were having these signal. He was having a1 cos omega naught t, he was having a1 cos 3 omega naught t, he was having a5 cos 5 omega naught t, he was having a79 cos 79 omega naught t. In that manner he was having a signal. Then he created a device which was adding up all these signal. Along with that, it was adding up DC value as well. So he added all these signal. First time what he did, he only took one harmonic. He only took first harmonic and DC value, of course. So 0th harmonic and first harmonic he took. This kind of waveform he would have got. Then he took 3 harmonics. Then this kind of waveform he got. Then he took not 3 harmonics till 3rd harmonic. Then he took till 3rd harmonic. That means these values he took. Then he took till 7th harmonic. That means 5 and 7. These values he took. Then he took till 19th harmonic, and then he took till 79th harmonic. So he kept on adding these values. He kept on adding these values. What he saw, he kept on adding these sinusoids. Sorry, he kept on adding these cosinusoids. What he saw was, he was never getting the perfect square wave. He was never getting the perfect square wave. There is always some ripple here. This is known as ringing or ripple. Basically, there is always some overshoot, undershoot, overshoot, undershoot, overshoot, undershoot, overshoot, undershoot, overshoot, undershoot, and then again when we are going to 0, overshoot, undershoot. Basically, you are not getting a clean waveform. This is your square wave, right? This is your square wave. But actually what he was getting, overshoot, undershoot, overshoot, undershoot, overshoot, undershoot, overshoot, undershoot, overshoot, undershoot, overshoot, undershoot, then again overshoot, undershoot. He added till 79. Then he sent a message to Gibbs. Okay, he sent a message to Gibbs. Then Gibbs added for a lot of times. Like he added like 1000 sample, sorry, 1000 till 1000 harmonic, 2000 harmonic. So he added all the possible harmonics. Then he saw that there is nothing happening to these ripples. These ripples are fixed, right? These ripples are not going. So there is overshoot, undershoot, overshoot, undershoot. These ripples are not even going, and which is pretty obvious, no? Why is that so? Why is that so? Look, this waveform is having discontinuity here. Discontinuity, right? This waveform is having discontinuity. At t equals to t1, this is having discontinuity, right? Cosinusoids are having any discontinuity? No. Cosinusoids are smooth waveform. They are not having any discontinuity anywhere. This will not have any discontinuity. This will also not have any discontinuity. This will also not have any discontinuity. And DC will also not have any discontinuity. That means you are adding up a continuous signal. What you are doing? You are adding up a continuous signal. And you expect that after the addition of continuous signal, you get something discontinuous signal. This signal is discontinued at t equals to t1 and at t equals to t minus 1. So what you are doing? You are adding up you are adding up continuous signal, and you expected that your final output should be discontinued. Is it possible? Adding up continuous and final output should be discontinuous. Is it possible? No. That means no matter how many cosinusoids you add, never ever you are going to get this clean waveform. So practically it is impossible to generate this particular waveform. Always there will be some ringing here. This is known as ringing, or you can say it will be having some ripple. Okay, and if you have simulated something, then you would have also seen these kind of things, that always there are some ripple. And this phenomena was given by Gibbs. So in statement wise it can be asked. And one more thing, he told that the height of this ripple will be 9% of this maximum value. Basically, if this value is, let's just say 2, then the height of ripple will be 9% of 0 or 0.85%. So 9%, sorry, 9%. 9% means 0.09 or 8.5% to be exact, that means 0.085. So 0.085 of 2, whatever the value you get, this will be the height of this ripple. So when he kept on adding up these values, after 79 he took 100, then he took 200. When he kept on adding up, he got to know that this ripple has become constant, and that is equals to 9% of the maximum value. And it is pretty obvious, right? Because if you are adding up continuous values, if you are adding up continuous waveform, then you cannot expect a discontinuous waveform. These waveform are continuous, right? If you just look at this sinusoid, sorry, if you look at this waveform only, this waveform is continuous. This is not discontinuous anywhere, right? This is continuous only. Because if you just look at this point, so just before this point, this value is there, and just if I zoom in, so just before this value, if I talk about at this point, let's call this point as t equals to t1. I have zoomed in this portion. So just before t equals to, let's call it t alpha. Just before t equals to t alpha, this value is there, and just after this value is there. So this is not discontinuous. At any point, this particular waveform is not discontinuous, but this particular waveform is discontinuous. So adding up some continuous waveform, you cannot get discontinuous waveform, and that was told by Gibbs. Okay, and that is known as Gibbs phenomena. So let's read out the statement of Gibbs phenomena. So what Gibbs is saying, the Gibbs phenomena refers to the persistent means that is always there. So persistence oscillation that occurs near a jump discontinuity, when a discontinuous periodic signal is approximated by its Fourier series. As more terms are added, then oscillation becomes increasing localized around the discontinuity, but they do not disappear. Even if you add them up, then these oscillations are not disappearing, right? Specifically, the Fourier series overshoot and undershoots near the discontinuity, overshoots and undershoots near the discontinuity. The maximum deviation from the true function settles at approximately 8.95% of the jump. Approximately at 8.95% of the jump magnitude, regardless of how many terms are included. Basically, if this magnitude was 2, so the length of this ripple will be 2 into 8.95% of 2, 0.0895. So this will be the height of this ripple. No matter from 79, if you go to 1000 or 2000, if you keep on adding up, still this ripple was there. The phenomena highlights a fundamental limitation of Fourier series. While they converge pointwise almost everywhere, here it is converging, the Fourier series is converging, but they cannot fully eliminate the ripple effect near discontinuities. So is this statement clear? It might happen that in the examination they will say that which of them is the Gibbs phenomena, then they will write down the statement and then you need to tick on the statements. This kind of question can be asked. Same goes for Drichlet conditions as well. So all these are not important from the examination perspective, but in the interview, these kind of questions can be asked. In like IIT IC interview or BARC interview, not in the interviews of MNC, like no MNC will ask all these kind of things, but in normal interviews like admission interview, in BARC interview or in PSU interview, these kind of questions can be asked because it will reflect that you have studied the course comprehensively, not some crash courses or anything. If you study the content comprehensively, then only you are able to understand these points, because these are not important for your examination, but these are important for understanding the subject. So I hope this is clear. Okay, so this was the Gibbs phenomena, Drichlet condition, and the polar form of Fourier series. So here our Fourier series ends. Okay, now we need to start Fourier transform. So from the next lecture onwards, we will study Fourier transform. So what was the requirement of a Fourier transform? We were having Fourier series, why we used Fourier transform, and what is the meaning of Fourier transform, that we are going to understand. Okay, thank you very much. I hope you liked this particular concept or liked this complete chapter as well. So I wanted to give a different feeling of Fourier series, and I hope I got successful in giving that particular feeling. Okay, thank you very much. You can comment down how you liked this how you liked this content and all these things. Yeah, thank you.